zone based on occupancy and demand was used. The HVAC system helped us to provide better thermal comfort to the occupants at lower rate of energy consumption. 40% reduction is observed using VRF system. Lastly, highly efficient LED lighting, which gives LPD of 5.2 watt per square meter, is used to further reduce energy consumption. After applying all active and passive measures, 67% reduction in energy demand were achieved. As per the shadow analysis, small building on the eastern side and north office block and roof of the north office block is covered in the month of the December. Hence, the roof of central courtyard and roof of south office block is utilized for installation of solar PV. In clear sky condition, through solar PV, 5,91,900 kilowatt energy is generated annually. This will help to provide 49% of total energy requirement.
Like energy, water efficiency also plays a very important role in order to make a building sustainable. So as we all know, water is our basic need, but the amount of water available on Earth is very limited. So as an architect, we think that it's our duty to use water wisely in our design. So to achieve water efficiency, we use 3R approach, that is reduce, reuse and recharge. So in reduce, we try to reduce water demand by using water efficient fixtures like taps with low flow rate, fixtures with aerators, dual flush systems like high flush and low flush, etc. By applying all these strategies, we are able to reduce 62% of water demand. The second R is to reuse. We have managed to reuse 20.7 kL of water on our site. Wastewater treatment plant has been proposed with 90% efficiency, which is catering to grey water and black water generated on site. Wastewater is collected from wash basin, toilets and urinals and pantry sink and get fed to the wastewater treatment plant. And treated water is being reused again for landscaping and for flushing purpose. Then third R is to recharge. Pune has an average rainfall of 820 mm, plus our site has potential of groundwater recharge. So 438 kL of water is getting collected from rooftops, hardscape and softscape from landscape and getting a recharge to the groundwater to replenish it through a recharge switch. Then this is our water balance chart. 64,000 liters is daily water requirement for landscape and for 1,000 people. Out of which 5,000 liters is for drinking water requirement, which we are getting from municipal corporation. Whereas 23 liters is water requirement for domestic water and flushing water. So as I said earlier, we have a wastewater treatment plant on site. So with 90% efficiency has been installed on site, which is recycling 20.7 kL of water, which is sufficing 100% of flushing water requirement and 25% of landscape requirement. Whereas remaining 75% of landscape requirement can be taken out from the borewell. By applying all these above measures, water demand from municipal corporation is got reduced by almost 75%. So total greenhouse gas emissions by materials throughout its life cycle, starting from extraction of raw materials to the end of life of product, is embodied carbon. One-click LCA software has been used to calculate embodied carbon. Embodied carbon of design case is reduced by 65% over the base case. Materials used in base case and design case were almost same, but the difference is glazing material and concrete. So in base case we have used singly glazed unit, whereas in base case we have used doubly glazed unit. And in base case the concrete used in normal conventional concrete, whereas in design case we have used a concrete with 60% GGBS content. GGBS is a byproduct of blast furnace using steel and iron industry, which can replace Portland cement and can reduce carbon emission by 900 kgs over the conventional Portland cement. So material plays a very important role in carbon emission by the building. So selection of materials without compromising user comfort and environment is one of the important steps in a building design.
Workplace well-being relates to all aspects of working life, from the quality and safety of the physical environment to how workers feel about their work, working environment, and working organization. As lighting is the most important aspect of working environment, we designed our office building in such a way that 75% of the regularly occupied space will get 100% glare-free daylight. A central open space between two buildings not only acts as a gathering space, but it will also boost the working environment by adding a natural element to the building while reducing the indoor temperature. After consideration of pandemic situation from last few years, we have provided a medical room for the office staff on the first floor. Other recreational and health and wellness facilities like yoga area, gymnasium are also provided in the office building. Our design goal is to boost productivity, reach a stage where employees are satisfied with their jobs and reduce environmental impact all at the same time. When it comes to the built environment, extreme weather events causing due to climate change and global warming are a cause of concern because they have a long-term significant impact on building performance and energy use. Pune is prone to flooding during peak monsoon season. Hence, our office building is on the plinth of 0.9 meter and is surrounded by plants, trees, and landscape is done in pervious material for about 20% of the total site area, which let the water seep into the soil, reducing water stagnation in the site. During the peak summer season, Pune's temperature reached around 44 degrees Celsius. To tackle this issue, not only planning and orientation, but also material selection, facade design, insulation and shading devices help by reducing the overall heat gain of the building. 21% of the site area being covered in landscape and high SRI paint being used on rooftops and landscape area reduces the overall urban heat island effect. Self-sustainability is the need of the hour. Hence, nearly half of the energy demand is sufficed using solar power plant installed on the rooftop of the site. Groundwater recharge on site will suffice the water demand for around 10 days. Though Pune lies in earthquake zone 3, which has the lowest level of seismic vulnerability, an appropriate structural system has been laid out for safety purposes. The most crucial part of any project success is its affordability. Many people associate green building features adding an extra element with initial cost and does not think about the operational benefits of the same in the long run. In our design, to boost the construction speed and reduce time and cost of construction, we have used flat slab technique, which reduced around 7 to 8% of the overall construction cost. 49% of the renewable energy being generated on site will not only reduce the dependency on the national grid system, but will also help to reduce environmental impact. Use of passive features such as orientation, shading devices, and use of active features such as energy efficient lighting system and HVAC system will reduce the operational cost by 67%. As 20% of the construction material is sourced locally, the transportation cost has been reduced. Using salvage furniture and other materials, the environmental impact are also reduced. Though the material selection such as DGUs, insulation, installation of solar power plant increase the overall construction cost of the project, but this additional cost can be recovered within just 1.17 years as these features reduce the overall energy consumption of the building. Passively designed structure, use of specific materials, lighting systems reduce overall energy demand by 67%, which will help in reducing operational cost of the building. Incorporation of concept of urban forest in a working environment promote carbon sequestration, which reduces overall carbon footprint of the building. Maintaining horizontal and vertical visual connectivity with the outdoors from the workspace speaks about the new ideas coming into the picture like IT-like sector. A natural element in a building improves health of the occupants. To improve it further, we have provided recreational spaces like gym, yoga and creche for working mothers. The three terms reduce, reuse and recharge make the building self-sustainable in case of water. Submission of this project to any green building certification system like IGBC will give it a super platinum rating, which will create our project partner's name in the market and which will boost the company's business in future. We believe that sustainability is the balance between environment, economy and ethics. And we hope that we have managed to achieve this balance in our project. We, the Team EcoTribe, would like to thank Solar Decathlon India for giving us this opportunity for designing and presenting such green building in front of all of you. Thank you.
Thank you.
Thank you, team. You gave a very insightful presentation. Let's hear the jury comments and take questions from them. Neeraj, I'll start with you.
Thank you. Presentation which gives you an insight in a quick way. That's how I term this few minutes which you used to help us get through it. Few questions which I have in my mind which I want to check, and this comes from the report as well. I wanted to understand how are you looking into the fresh air system coming to the building, because you spoke of the indoor air quality. And connected question to fresh air also is, while you are installing a VRF system, at the same time you are talking about the AHUs also getting installed. So I want to understand what is the background to that, how you have thought about it.
So we talked to our consultant from Decathlon about this, and the pressure will be taken inside using the AHU installed on the terraces, and the fan coil unit has been installed on the top of toilets for circulation of air. And
Okay. And second question related to this is, you also have highlighted the use of UVGI in the AHUs. What exactly and how exactly do you think it will be installed and then used? Do you have a snapshot of that also? Because this is the second one in relation to what I asked the previous one. Yes.
no, unfortunately, we don't have the snapshot of it, but yeah, we'll
Okay.
consider.
Sure, no problem. Thanks. Over to you, sir.
Hi. So again, very crisp presentation. I would just like to give a few comments, maybe not a question kind of thing. Specifically on the embodied carbon. Okay. So embodied carbon, I think maybe you misspoke or something like that. Can you just you said there were two things that reduces your embodied carbon. One is glass and one is the cement.
Yes.
Cement, DGBS, that cement you're using instead of ordinary Portland cement. And then for glass, you said base case you're using what, and worst case you're
Single
using
glazed
what?
unit in base case and DGUs in design case.
Okay, so when you spoke, I think you flipped it.
Oh.
Then second thing, the thing is that I'm not very sure if single clear unit, you said proposed case, the DGU actually will be more, will have more embodied carbon associated with it than a single phase unit. So I'm not sure if because of that you're reducing anything. Whereas one thing which you could have probably thought of is that at the end, at one of the last slides you said all your materials are local.
Yeah.
You know that local material bit also helps you in your embodied carbon, right? So basically that, I think I won't really get into any other point but then embodied carbon with that.
Thank you.
Thank you for the presentation. It was very nice. So just had one question actually and a follow from that. Did your project partner give you a clean plate, or did you start with something from the project partner before you did what you've done?
No.
Did he just give you the site boundaries and you started
We started from the scratch.
from scratch?
Yeah.
How did he react to your work? Have you presented your work to him?
Yeah.
What does he think about your work? Will he build it if he gets an opportunity?
So yeah, we showed our work to the
Yeah.
project partner,
Mhm.
and he liked the concept of urban forest incorporating in a commercial space like office-like structure,
Yeah.
because they also have the same issue that workers, like employees, feel exhausted in a closed claustrophobic environment.
True.
So they were happy with the designs,
Yeah.
and they are thinking to take it forward, but there are some like financial concerns and that they have.
So the one observation I have there is, since you've been speaking to project partners, you put up a new design and fresh concept. On the affordability, my advice would be to bring this out in terms of numbers, which makes sense to a builder. 15%, 45%, 67% makes sense to us as designers. Doesn't make sense to the builders putting in money. So my advice would be to convert that into money terms so that you could put your proposition across much better.
Okay.
Thank you very much. for your time.
Thank you so much.
Thank you, jury members. Thank you, team EcoTribe. So now let's take a 5-minute break and get ready for the next presentation. They're not here. Team footprinters. Footprinters, right? Okay. So please be seated. When I say your, like, when I go on full screen mode, you can just come here and start. Okay? And when I say your time starts now, that's the moment you will start your presentation. Alright. Our second presentation is from Team Footprinters. They have worked on a net zero office in BKC, Mumbai. Their project partner is WeWork. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have the 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we'll have a 10-minute for a Q&A session. So you have to keep your answers direct and to the point. Okay, team, the stage is yours. Your time starts now.
Good morning, everyone. So our team Footprinters, has redesigned an existing building for WeWork in BKC. These are our team members and our project and industry partners. So WeWork is a company that provides shared co-working spaces to freelancers, startup companies and large enterprises. These three are the office types that we have incorporated in our design. Our site is located in BKC, Mumbai, which is the commercial hub of Mumbai. And the Mithi River is located to the north of the site. So this is the site analysis. The wind primarily flows from southwest direction and year-round from east to west to east direction. The solar radiation is plentiful on the site and rainfall as well. So the problems in the existing structure are as follows. Since the site is adjacent to the Mithi River, it faces the issue of flooding almost every year. This is due to the fact that the Mithi River has faced problems such as encroachment, due to which during monsoons and heavy rainfall, the deluge is experienced. The existing structure is missing major green building systems such as solar panels as well as rainwater harvesting.
Architectural design. The design approach started with the site context and climatic analysis of the surrounding. The site is elongated in east-west direction, which causes the problem of solar heat gain from the southern side. To encounter that, openings are given on the northern sides while the service cores are provided on the southern side. The form development of the building started with the context of the site, allowing more northern lights into the building. The building was then divided into two entities to create a central plaza. Many balconies were created on each floor to regulate the airflow throughout the building. Staircase block was added to link the two masses. Floor voids were created to reduce the wind loads on the structure as well as to provide a buffer zones for the employees. The roof was tilted on the southward direction to maximize the solar sunlight. The double height ground floor comprises of open gym, cycling tracks and green spaces, which helps in improving the quality of health of employees. The building is designed into modules of 3, and the building has 16 floors in all. The four modules have been stacked upon each other with one community space and one green floor area. The green floor area acts as buffer zone for the employees above and helps in air movement. The first floor is the community center, which comprises of sleeping pods, library, indoor games and cafeteria. The second floor is a workspace, which comprises of meeting rooms, cabin, flexible workspace and lounge area. The pillar slabs, DTO glass and terracotta fins on the facade help in minimizing the solar heat gain by minimizing it by 30%. It is very important to cater to the health and well-being of the employees who are constantly working in front of the laptops. Some of the strategies to cater to that is by placing the workspace on the northern side and by providing glass partition walls. Also, many passive design strategies have been used, such as horizontal and vertical shading. We have provided recreational spaces as well as green and silent zones in the structure to improve the health of the workers. Mumbai is vulnerable to many weather events. To make our building withstand all those weather events, we have provided many strategies for lightning and thunder. We have provided protection devices which helps in catering lightning and thunder by transferring it to the ground directly. Shock absorbers have been used to prevent the building from collapsing during the earthquakes. The building is tilted on the ground floor, and also by providing proper drainage system. And structurally, we have provided deep foundations, which helps in protecting the structure from frequent floodings. To make the building more resilient, fire safety services have been used in accordance with the NPC. To counteract the heat wave, the terracotta fins have been used on the facades. The terracotta fins have the gap in between, which is closed during the daytime and act as a thermal insulating cladding to minimize the heat gain within the building. And at night, it is manually opened up, which helps in passing the air into the structure at night and cooling the interiors of this office. The utilization of natural materials such as terracotta, clay pots and plants, natural plants have also been used to reduce the heat gain inside, reduce the heat gain. During the power outage, the DG backup and solar battery backups have been provided in designated areas.
Moving on to energy performance. Looking at the temperature map of Mumbai, the temperature usually ranges from 24 degrees to 35 degrees throughout the year, especially in the 7 a.m. to 7 p.m. Range, which will be the working hours in the office. Due to this, the load on the HVAC system is very high, and we work towards decreasing the microclimate around the unit to increase the efficiency and decrease the energy consumption. In a standard HVAC system, the heat that is absorbed from inside the room is ultimately absorbed outside by the outside air. So, if we could reduce the temperature of the outside air, more heat could be absorbed and this would increase the efficiency of the system. Thus, we proposed a pre-cooling system built around the condensers, which would create a cool microclimate around it and decrease the temperature outside the unit. This system is based on direct evaporative cooling, which is better than sensible cooling because in evaporative cooling, both temperature and humidity change along the lines of constant wet bulb temperature. The product that we have used for this has an efficiency of 85%, and by using this formula, approximately 6 degrees of a temperature drop was possible outside the unit. By running a simulation of this system on the platform sim scale, we saw that there was a decrease of almost 40% both in temperature as well as pressure around the HVAC system. This brought down our energy consumption from 10 lakh units in the existing building to around 6 lakh units per year. However, the design still relied on conventional HVAC system for all of its cooling needs, so we needed a passive design strategy which tailored to the climate of Mumbai, which did not promote dry eyes and spread of viral diseases, and was also powerful enough to replace the conventional system at least for a few months. Hence, this is where our two-stage evaporative cooling process comes into place. Due to the two-stage cooling, the air could be brought down to a much lower temperature and was thus not capable of containing high amounts of humidity. Looking at the humidity levels in Mumbai throughout the year, the months of January to March and November to December were comfortable and humid, and in these 5 months the cooling by the two-stage evaporative cooling would be sufficient, and thus in these 5 months we have proposed that system. The system would be installed on the south facade where the winds are most prevalent. The south facade will have projections which will be facing the southwest direction. So the winds coming inside the structure through these grills would then flow through the two pads, and then ultimately the cool air would be supplied to the office spaces. The fans and the blowers account for only 10% of the energy as compared to the conventional HVAC system. Thus, in this calendar, you can see the 5 months for two-stage evaporative cooling is combined with 7 months of conventional HVAC with pre-cooling. After all the calculations, our HVAC cooling load was brought down to 4 lakh units as compared to the 10 lakh units in the existing building, which accounts for a 60.3% reduction. For lighting, the lighting equipment inside the building was given in accordance with IS 6665, which provides the lux levels for each space, and also considering the solar radiation coming into the workspace. And after calculating the total energy required, we got an energy performance index of 43.3 kilowatt hours per meter square. The solar panels on the rooftop generate electricity of around 5 lakh units per year, with varying monthly values depending on the solar radiation. Moving on to innovation, We wanted our innovations to solve mainly 4 problems, which were generation of electricity, purifying air, conserving water, and promoting health and well-being. Our first innovation of electricity generating tiles are placed in the lobby and reception areas where the footfall of the building is maximum. When stepped upon, these tiles generate a turbine which generates electricity and has this mechanism. Our next innovation is a device called the water seer, which draws in air through its blades and passes it down to an underground chamber where, because of the decrease in temperature above and below ground, the water vapor is condensed and collected underground. This device was originally developed by a company called Water Seer, and we have modified it to also collect rainwater. It does not require any power sources, does not produce greenhouse gases, and has simple machinery and could potentially run forever. Our last innovation is a device called the Flora Fountain, which has paper plastic leaves which are covered in a resin which contains sodium carbonate. This compound reacts with the carbon dioxide in the air, absorbs it, and then releases oxygen into the workspace by a process called humidity swing, which was originally developed by Dr. Klaus Lackner. Moving on to water.
Buildings play an important role in managing and utilizing water. Thus, the water in the building is sourced from municipal corporation, which provides fresh water. All through. Then it is stored in underground tank or storage tank, which is then pumped to OHT, and from there it is passed on to the building. The other sources are rainwater, which is harvested and collected for further use. The surface the third is surface runoff, which includes systems like gutter and drainage systems. In the building, water is used for different purposes like drinking, cleaning, etc., which produces wastewater, which is then went for treatment, and the grey water is used for flushing and irrigation. Our aim was to minimize the water consumption, maximize the alternative water use, water sources, minimize the wastewater generation, and return the grey water to the source. Thus, we have proposed the 3R system, that is reduce, reuse, and recharge. In this, we have moving towards reduce. We have used low flush fixtures, which adds. In the base case and proposed case, we have found the 22% reduction in domestic water use, 56% reduction in flush water use, and total occupant water demand reduction was 36% after using the low flow fixtures. Keeping in mind the catchment area, rainwater harvested, after the calculations, we have rainwater harvested. We have calculated the amount of grey water generation. Thus, all these calculations are being done and used. The rainwater in the monsoon, using the sites potential to its maximum, the water is during monsoon. The water stored can be used for 4 to 5 months, which is then taken for treatment, which is a sustainable measure we have taken for the building, which includes mechanisms such as physical filtration, adsorption, chemical reaction, and biomicro degradation. This is we have proposed a 3-tank system. In the first tank, the cannon lily will be used. This is used because it adds blossom. It can thrive in unclean water, and it is available in Mumbai's environment. In second tank, we'll use aquatic plants with fibrous roots. Water hyacinths and duckweeds would be used for removing water contaminants. Third tank will have water umbrellas and water lilies, which will help water from not evaporating. and freshwater fishes will be provided so that it adds the productivity. Thus, we have got the 75% reuse of grey water. This is the water cycle diagram in our building. For recharge, we have used rainy filtration systems. Thus, we have got 36% reduction in water occupant demand, 75% reuse of grey water, and recharging the groundwater table. And the remaining grey water would be the treated water would be drained into the Meethi river. Engineering and operations. Our building is 18. The building existing is 18-story high, which was made 5 years back. That is a WeWork building. So we are going to use the foundations, which has reduced 3.2 tons of embodied carbon. Before that, these are the testings that would be done, and the precautions taken would be step-by-step demolition, temporary support, controlled demolition techniques, and prioritizing safeguard foundation elements. Biomass lightweight concrete is used as it is lightweight and insulating. Floorings will have decking sheet and concrete poured. Other features are green roof, filler slab, raised access flooring, DG double glass unit, and cork will be used for insulation.
Moving on to embodied carbon. These are a base case of materials after referring to the National Building Code summary. This is our proposed case of materials, and we have reduced some of the base case materials with materials of lesser GWP values. We'll go into that with details. In the slab system, we have reduced the concrete by 50% by using terracotta filler pots. For the walls, the concrete walls have been replaced with fly ash bricks, which is completely made of waste products and requires almost no energy to produce. For insulation, we have used cellulose insulation, which has a negative carbon footprint and absorbs carbon dioxide throughout its cycle. In the interior and exterior, we have used corkboard and paint respectively, which has a much lower value than veneer and aluminium cladding outside. For curtain glazing, cellulose insulation has replaced XPS insulation, giving us negative carbon emissions. And all in all, we have 46.8% reduction in embodied carbon emissions.
So talking about affordability, our base case, our proposed case is 6% more expensive than our base case. And for the base case, we have referred to the state schedule of rates, and for the proposed case, we have referred to company and product brochures. So first, to achieve affordability, we have reduced the construction cost. This we have done by reusing concrete from the existing structure as crushed aggregate and reusing structural steel. Structural steel can be reused up to 90% from the existing structure, and reusing the existing foundation. Filler slab has been used over conventional slab, which reduces the amount of concrete and steel. Secondly, we have tried to reduce the operation costs of the building. This has been done by integrating solar panels, which once installed bring down the cost of electricity largely. Adiabatic cooling over conventional HVAC. A well-integrated building management system can also play an important role, and smaller measures such as energy efficient appliances on a smaller scale. This is the calculation for the savings due to HVAC. So value proposition. Value proposition for the project partner lies mainly in the land itself. The time value for money for land in BKC is constantly growing exponentially and will continue to do so. These are the percentages of savings that they will achieve through our new proposed design. For the end users itself, WeWork as a company offers an array of facilities such as global collaboration, flexibility, WeWork Labs, which is an incubator platform on a global level, which helps grow businesses, business solutions, which provides HR, financing, admin, and amenities, which we have provided throughout our building as well. So the main part of choosing WeWork is to work how you want, which is you can work either dedicated desk, private office, or a full suite office. You can work when you want. You can upsize or right size your business as and when required. And you can work where you want. You can work near to home or across 40 plus locations in India and many more globally. This is summarizing our active design strategies which we have integrated in the building. And these are the passive design strategies that we have integrated. Thank you.
Thank you, team footprinters. You finished well in time and have delivered really well. Let's hear the jury comments and take questions from them. Samit, I'll start with you.
Thanks, team. I have one observation. I was looking at your presentation. You presented some energy numbers everywhere, and all of these are simple formulae, right? I mean, delta T or something into number of hours. So there are net simulation software available because you have different deltas during the day throughout the year. My suggestion would be to use software to better present the data. You'll have a very different result from what you've got from straight formula. That's one. I think you looked at a lot of different systems in your work through this project. I'd also like to see you're digging deeper into those systems, trying to see how they're integrated into a building. You've given some innovations here. How do those innovations come out in your building itself? Innovations are there, you can Google and get them, but how do they integrate them into the building? Work on these, and I think you'll be better professionals in the years to come. Thank you.
Thank you.
Okay, hi. I think in comparison to what your report was, I think this was a vast improvement. And I'll tell you that because in your report, I think the narrative was a little disjointed. It was very difficult to follow why you are doing certain things. So some things have come out better in this, okay? So that's a good thing. Like Samit said, there were a little too many systems, even in the HVAC part of it. And I don't know whether that was accounted from the cost, but this is way too many systems for one building, okay? And I'm not sure how it is going to work out. But again, as I said, that at least the narrative was much better than what was in the report. One small question I had, just tell me, is it net zero energy? Because you said your EPI was 43, and you said that there was some renewable energy that you are generating. Did you see whether it was, were you able to achieve a net zero energy status?
So our total energy consumption was around 9.7 lakhs. Out of that, 5 lakhs was generated by solar power cells. And some of the innovations, for example, the electricity generating tiles, we were not able to calculate how much energy was being generated. That is why we do not have a conclusive answer if we achieve net zero.
Yeah. So that is why very good, because the thing is that you put the innovations, but then how does it work with the rest of the building? That is important to see. Okay.
Let me begin with all of you have done a good job as far as the way you have to approach the subject and the topic is. Okay. When you present, be strong and be positive about what you have done. You are not appearing to be strong on what you have done, trust me. All of you have done a good job. Doing it independently is not a small thing. Doing it for the first time is not a small thing. So a good job done. Be confident of your work. Few observations other than good work and thoughtful work around water performance. Thoughtful work, I would say. Just to add to what Saswati said, yes, we observed that we have not been able to achieve net zero. That's fine. Achievement, not being able to achieve is fine. Make an effort to see whatever innovations you are trying to bring in, how you conclude that. That's very important. Another piece which I observed was more from the HVAC side. You are doing adiabatic cooling. It's not easy. You are being very bold to adopt that for a humid climate. It is generally taken for the dry climate. Mumbai you will not find, or in case you find, to my knowledge I have not seen, you will not find any of those facilities with adiabatic cooling. You cannot achieve 60% saving. Theoretically you may. Why? I'm not trying to discourage you. See, as I said, our objective here is not to see what have you achieved. Our objective is to how have you approached. That's important for us. Most of the energy consumption in any building, if you pick up, happens for a tropical climate like India, that will happen from an April to a September. And Mumbai and Chennai kind of climates, which are hot and humid, these are the peak times where the loads are maximum. Your application and usage of technology out here is taking care of the balance 5 months, not the peak season or the peak hours. So it's impossible to achieve that, what you have achieved. I will suggest all of you to not leave it here. You have taken a bold step. Please take it forward. Wherever you find time, conclude that and figure it out. 60, 50, 40. I'll be happy and glad to receive emails and communication from you saying that we have done this. Okay. Please take it forward. It's a bold step. And good work. I wish, I don't know, a question to you. How much hours did your project partner spend with you on this? How many hours?
So they helped us with the initial requirements of the building, how many floors, what all spaces they needed, and they helped us with the existing energy consumption levels and water consumption levels. After that, it was all this.
You really don't support, I could see that. That's fine. And that's the reason I have this question. Remember, be strong, be confident of what you're doing. That will take you to a different level. Thank you.
Thank you so much.
Thank you.
Just one request to be sitting there. When the presentation is on, nobody moves outside, please. It disturbs attention, what we want to give. Each one of you are prepared for it. You want to give that with respect and time. Just don't move out when they are presenting. Anyway.
Thank you, jury members. Thank you, team footprinters. Now we'll be taking a small 15 minutes tea break before we begin with the third team. Tea will be served right outside the hall. Folks online, I request you to stay tuned and please be with us to support the upcoming teams. Thank you. Welcome back to the presentations for the office building divisions. Our third presentation is from Team Gaia. They have worked on Infosys Software Development Park in Hyderabad. Their project partner is Infosys Limited. Team Gaia, you will have 20 minutes to present your work. At 15 minutes, I will ring a signal like this. I will stop you and ask you to end your presentation at 21st minute. After that, we will have 10 minutes for Q&A session. So please keep your answers direct and to the point. Okay, team? The stage is yours. Your time starts now.
When I say the word office, most people would imagine something like this. The daily routine of coming to work and staring at the same artificiality. Now imagine yourself working in an office that feels more vibrant. A place where you're not just confined to your desk, but you can easily move around, collaborate with your colleagues using flexible workstations that adapt to your needs throughout the day. Doesn't that sound refreshing? Metropolitan cities like Hyderabad experience energy waste and heavy energy consumption, high maintenance and operational costs, mundane and inflexible environments with poor indoor air quality. However, a net zero office building can overcome these challenges. Greetings, we are Team Gaia. We've partnered with Infosys Limited to design a net zero energy office building for their software development blocks 8A and 8B in Hyderabad.
Talking about project summary, we are designing a workspace for about 10,500 IT professionals working 5 days a week from 9 to 5 p.m. We have a built up area of SDB 8A and SDB 8B. About SDB 8A has 22,810 square meters of built up area and SDB 8B has 27,936 area. Apart from this, SDB 8A is a G+8 structure and SDB 8B is G+12 structure. We will be following the footprint of the Infosys given footprint. Other than this, we are only having a buffer of 5 meters. The construction industry accounts for more than 39% of global carbon emissions. We are here to create a net zero energy building. Our site is located in Hyderabad, in Telangana, as a part of phase 2 development of the SEC block in 65 acres land of SEC campus, in which we are considering 6.6 as 6.6 acres of our site, which consists of 2 blocks. Our project goals in line with the project partner are net zero energy, net zero water, energy performance following standards such as ECBC, LEED, and creating new innovations and engineering operations, giving flexible workspace, optimum lighting, reducing use of radiant cooling and reducing embodied carbon. According to NBC, Hyderabad has a composite climate with hot summers about 38 to 40 degrees centigrade and cool winters about 16 degrees centigrade, with 60% relative humidity and 838.6 mm of annual rainfall. In accordance to this climate, the following strategies were implemented, such as staggered balconies, voids in the building, venturi effect, with a 13-degree tilt in the office tower B building, and vertical trims to cut glare and mutual shading of the buildings. Coming to the various daylight metrics which we have explored and analyzed. First one is the spatial daylight autonomy. Minimum of 300 lux was occupied for 85% of the occupied or the operative area. Apart from this, we have a useful daylight illuminance of 100 to 2000 lux for 60% of the floor area for 90% of the daytime, and we have an annual sunlight exposure of not more than 10% for 250 hours annually. Coming to the architectural design,
We have implemented various strategic approaches such as staggered balconies, drought-resistant landscaping, and footbridges connecting both the towers. These above spaces, staggered balconies on the south facade act as buffer space and reduce heat gains, and xeriscaping for water conservation, and the footbridges foster connectivity within both the towers. Further, in terms of the planning, the tower invites us into the atrium spaces with the service course on either side of the wings. The atrium spaces provide visual lighting and visual connectivity and make an architectural statement, and they also create a continuity between the levels. Further, as you walk in further inside, we have hoteling workspaces and cafe areas. These hoteling workstations provide flexibility and employee autonomy, while the cafe area acts as an informal meeting and interaction spaces. Ascending to the upper floors, a diverse range of workstations has been incorporated, including the workstations along the light wells, which have been incorporated with planters such as snake plants and spider plants, and while the modular and configurable workstations have been strategically placed along the windows to enhance productivity. Further, the linear workstations and smaller focus workstations have been provided in the ODC areas. These were provided for structured and organized working and also for better space efficiency. Further, these are a typical ODC floor plans that is through floor 6 to 12 and the typical food court plan on the floor 8 in the tower B. Further, here are some of the sections which represent the workstations, the light wells and the atrium spaces, which show how the natural daylighting has been brought into the building and reducing the usage of artificial lighting systems. Further, this section is again from the tower B, which represents the workstations and the pantry areas along with the fire exits, which is as per our NBC norms. Further, these are the workstations and launch areas which have been rendered and represented of our various spaces.
The span of the building imposed daylighting issues within the spaces, which was tackled by our innovation. Solar light tubes were used within the light wells to carry out multiple reflections of incident light and diffuse light throughout every flow plate. Daylight penetration was further achieved using light shelves that reflect incident light to the reflective white ceiling, which in turn lights a wider space efficiently. Light wells and 40% window wall ratio facilitated the improved daylighting scenario. After multiple iterations, we were able to achieve an output that aligns with our project partner goals. Electrochromatic smart glass that contains liquid crystals polarizes the window using light reactive sensors. Smart glass integrates extra low voltage system and blocks direct sunlight. These strategies resulted in 86% reduction in lighting load, hence higher energy efficiency. Factors affecting the health and well-being of our occupants. Temperature and humidity is mitigated using radiant cooling. Lighting is handled by the use of light shelves, atriums and light wells. Stagnant spaces are replaced by open spaces, atriums and balconies. Outdoor and indoor air quality is improved by the use of activated charcoal planter boxes, non-VOC materials and selective indoor plants. Ergonomic comfort is achieved by the use of kneeling chairs and unicycle chairs in informal spaces. Coming to the engineering and operation of the building, we have used autoclaved aerated concrete because of their lightweight, fire resistive, excellent sound insulation and lower thermal conductivity. These sections represent the typical structural details. VAV integrated with radiant cooling system has been installed in the open floor plans. Cabins and meeting rooms are equipped with VAV systems. The adjacent diagram shows the represent composition of these slabs. We have considered ECBC as base case here, using VAV system with one chiller and cooling tower of 2,394 tonnage. Whereas, in proposed case, we are using a VAV with radiant cooling system consisting of a cooling tower, empty and empty chiller, resulting in 52% reduction in tonnage. The design involves energy efficient lighting system and strategic ducting and efficient electrical system. We are able to reduce energy used for lighting from 22 to 3 kWh per square meter and 79 to 31 kWh per square meter for equipment system.
The building management system automates the overall functioning of the building. The process starts with data collection through multiple sensors that are present throughout the building. This data is then processed with different types of routers and then run through a central SCADA controller. All of this data is then further processed and represented in the form of GUI or graphic user interface, which then alerts and informs the occupants. We have considered IGBC standards for water efficient fixtures and an MBR type sewage treatment plant in the plumbing system of the building. The typical washroom plan demonstrates the number of cubicles, sinks, urinals based on MVC once again and the general plumbing operations of the building.
Further, the embodied carbon of the building was reduced from 1730 to 1275 emissions per functional unit. This was done using locally sourced building materials and efficient massing and envelope design, replacing the materials with low embodied carbon potential materials. Further, these graphs show the variation between the ECBC base case and the proposed case values with respect to the emissions, initially which was achieved about 15.15% in the carbon content with respect to the proposed project. And here is a composition of the roof and the wall where we have used autoclaved aerated concrete, carbon negative plant-based insulation and timber window frames, aircrete plaster, which help in the significant reduction of our embodied carbon. Therefore, we have reduced the overall embodied carbon emissions by 26.3% from the base case ECBC proposal.
Early warning systems warn the occupants of disasters and a calculated 93 days of autonomy help in essential operations of the building, during which recovery plans can be implemented. Structural integrity and seismic, fire and moisture resilience are major advantages of the AAC infrastructure. Simple plants and shear walls work with the low seismic risk of Hyderabad, while on-site energy backup helps in the adaptive capacity of the building. Threats to the building due to climate change can be mitigated using radiant cooling, optimum orientation, massing, fenestration, and a 40% window wall ratio, amongst other factors. Fire disaster is mitigated through a functional fire escape plan of both the towers A and B, supported with disaster supply kits. Additional energy from the renewable sources is stored in sodium-ion batteries to provide resilience to the building electrical grid during disasters. 1 meter plinth height surface traps in a well-designed drainage system manage the effects of flooding. By implementing innovative dustbins to help in appropriate segregation of waste and a plastic-free environment with the use of recycled paper products, the building produces 1365 tons of dry waste annually. The dry waste is sent to the biogas plant to generate energy for the building. Wet waste from the building, meanwhile, undergoes on-site aerobic composting and gets used as manure for xeriscaping. E-waste is sent to recyclers.
Coming to energy and HVAC, we have attained an EPI of 60 kilowatt hour per square meter per year, which is challenged by ECBC base case of 143 kilowatt hour per square meter per year and our project partner requirement of 65 kilowatt hour per square meter per year. So basically we are reducing the energy demand by 120 lakh kilowatt hour to 51 lakh kilowatt hour. Coming to the energy consumption comparison, we are again reducing here by 58% from 143 kilowatt hour per square meter to 60 kilowatt hour per square meter. This is how we have achieved all this. First, by giving efficient lighting controls, energy efficient equipment, use of renewable resources, reducing waste by using building management system, and reducing energy loss. Coming to the lighting controls, we have used two types of lighting controls, which is the automated lighting control and the application based. The automated lighting control uses motion sensors and illuminance sensor to control the intensity of light, and the application based sensor uses desktop and mobile applications according to the user. Coming to the PV is basically the rooftop PV is located on top of each tower, on tower A and tower B. So that both the towers including generate about 30 lakh kilowatt hour per year, and the PV farm in the same campus is generating about 16 lakh kilowatt hour per year, and the biogas generates about 6 lakh 96,000 kilowatt hour per year. Coming to the photovoltaic solar PV, we are using a bifacial solar PV. We are using a bifacial solar PV with solar tracking, which helps in energy simulation. Other than that, coming to the biogas, we have about 10,500 users who produce about 1,365 tons of waste annually. So this waste is collected, pre-processed, and it is sent to the anaerobic digester, which is digested, and biogas is collected. This biogas is combusted, and then the energy is produced using turbines. This energy is again stored and supplied to the facility in later stages. Coming to the HVAC system. The HVAC system, we are using a VAV system with radiant cooling, in which we are using a cooling tower, LT chiller, and an MT chiller. So basically, the LT chiller uses water to cool the AHU, where it cools the water to 8.9 degrees centigrade and sends it to the AHU unit. The AHU unit, basically, the coil in the AHU unit cools the air to the operating space, and the empty chiller, again, it also uses water to the cooling coil, and there is radiant cooling. So the empty chiller cools the water to 16 degrees centigrade. So this 16 degrees centigrade water is pumped through the radiant cooling pipes in the ceiling. So this internally cools the space. So we are attaining the set point temperature of 24. So this 24 is all round maintained throughout the operating hours. Coming to the HVAC system specifications, we are using an LT chiller, the electric EIR chiller centrifugal system with a tonnage of 399 and an empty chiller with tonnage of 731 and a cooling tower which is of cross flow type and a tonnage of 1148. Coming to the specifications of AHU extract fan, which is of a variable volume with efficiency of 90% and fan efficiency of 70%. And condenser pump is also of variable speed with motor efficiency of 90%. And the MT pump and LT pump is also has a motor efficiency of 90% and with a variable speed. Hence, adding up all these, we are generating an energy of 53,37,616 kilowatt hour per year, and this is divided into demand and resilient purposes. With this, 51,38,587 kilowatt hour is used for demand, and the remaining 1,99,000 is used for resilient purposes. So, according to this, we are achieving a net zero energy building.
Using the proposed case of efficient water fixtures, the water requirement has been reduced by 59%, resulting in per capita water requirement of 15.35 liters per capita per day. This in turn results in a total water demand of 48,465 kiloliters per year. The total water collected from rainwater harvesting and the treated water amounts to 61,912 kiloliters per year, therefore helping us achieve a net zero water cycle. During the rainier months, rainwater is collected and used to satisfy the potable demand of the building. Meanwhile, the remaining water is stored in underground cisterns in the northwest part of the site to be used during the drier months. The sewage treatment plant, also present in the northwest part of the site, utilizes MBR technology. The resulting grey water and black water are treated in the STP and utilized in the building as flush water and in the HVAC system.
Further, moving on to the affordability of our proposal, we aim to address energy, water and construction by achieving 58% reduction in energy consumption by using optimum window designs and on-site renewable energy generation, and lower water consumption by low flow fixtures and rainwater harvesting, leading to 59% reduction. Further, less harm to the environment by utilizing low embodied carbon materials, leading to 28% reduction, thus resulting in an overall savings in our electricity, water and construction bills. Next up, we showcase the capex cost comparison, highlighting the difference between the ECBC base case and the proposed case for various elements associated in the design. Further, energy efficient system on-site renewable energy generation leads to maximize the OPEX cost, resulting in reduced energy consumption from the grid and lowering the long-term operational costs. Now, addressing the OPEX cost savings, focusing only on the cost of MEP services, as it should be noted that the project partner owns the land and intends to occupy themselves, therefore eliminating the need for rental returns. We are calculating the ROI based on the electricity and water bills plus the maintenance cost of the government tariff rates. We have achieved an annual return of 14.55% every year on the initial investment of MEP services. Lastly, our aim and solution align with the ESG goals of Infosys within the value proposition. Our solution encompasses the energy efficiency, waste management, positive work environment and emergency response planning, and establishing good office work culture. Further, these links to the value creation of the top line growth of Infosys cost reduction, productivity uplift, and investment asset optimization. All of these features mentioned have been contributed in our design of a multidisciplinary functional office building adapting to the parameters of Infosys, our project partner, which are close to real life requirements. So thank you, Solar Decathlon India, for this opportunity, and thank you for your time.
Thank you, Team Gaia. Your team really did a very good job. Now let's hear the jury's comments and take questions from them. Shashwati, I'll start with you.
Hello. Okay.
Hello, ma'am.
So, I have one question. One is that for renewable energy generation, you say there are three things. Right? You have the rooftop thing, you have the PV farm, you have the biogas generation. Rooftop is definitely on the building and will be used by the building itself. PV farm and the biogas generation, won't that be used for won't that be shared by other buildings on the site also? Because you are using that as part of your whole narrative on how your building is net zero energy, right? But I think if it's a PV farm, is it being exclusively used by that building or is it being shared by other buildings?
It is being exclusively used by our building because it's proposed within the site limits.
Within your site limits,
Yeah.
okay. Alright. Fine. And yeah, another question was on the roof that you have. You in the section you show an AAC roof. Now, how does that structurally work? Well, an AAC, is it AC block somehow that you have put on it, or is it concrete that you have poured?
Yeah, it's AAC concrete. We technically approach it like an RCC building, but we replace the concrete with AAC concrete or
With foam concrete,
Yeah.
really.
Yeah.
So basically, it is foam concrete probably, and you also have reinforcement in it.
Yes.
Is it? Okay, I'll leave those technical details. Maybe we can talk about later. All of that.
Thank you, sir. A good slideshow in terms of how you would like to take us through the plan, what you presented to your project partner. A couple of questions. When you are using an empty chiller, you said an LT and an empty chiller. Empty chiller is helping you save a lot of energy. Why are you not using complete system as an empty chiller system? Why two types of chillers?
So one, we are basically using empty and LT because the LT chiller takes care of the latent load and the empty chiller takes care of the sensible load. So another thing, we are not using the single system where an LT chiller to cool efficiently because of the equilibrium we'll have to cool efficiently. We are not only using empty chiller because we are cooling it to only 16 degrees. If we are using only LT chiller, it has only 8.9 degrees, which again leads to a problem of condensation and water droplets on the ceiling. So we are using two systems where empty chiller uses radiant cooling on the ceilings and LT chiller which cools the air efficiently.
Okay. Second question is, how is the design what you have proposed to your project partner different from their existing designs? Because we all know that they have been using radiant cooling and all other concepts which you described.
So basically,
what all new things did you propose to them which is not in their existing design?
So as a part of radiant cooling was mentioned as a particular thing that we have to follow. We have to use radiant cooling. That was one thing that the project partner told. Other than that, we have come up with innovations, light shelf and all these functions which are not being implemented in the original building, but we are doing it there.
Like, could you tell one or two of them which you?
So like the light tubes, the light which we are using so that we have an efficient daylight, which we are attaining about 85%. And can we show the slide?
Please do.
Okay, to answer that question, apart from the Infosys requirements, here we are trying to achieve as close as we are trying to achieve the goals that were intended by the project partner as close as we can. So apart from that, solar light pipes were a new invention that we had added upon, and Infosys blocks with the intricate light wells and HVAC proposals were also one of the things. So we technically try to split the space, make even an open, a good contact with the
outdoor daylight and indoor. So we try to implement more daylighting factors.
Okay, thank you.
Fundamental question. What is LT and what is MT?
So LT is low temperature and medium temperature, that which we gave a name.
Yeah.
Again, that was 8.9 degrees higher again.
So I suggest don't assume that everyone here will be aware of it. You should expand that. And how did you arrive at the cooling load? You've shown some numbers there. I've not seen how you step by step arrived at that. How did you arrive at the cooling load, which you I think 1,000 tons or something?
So again, this is through design simulations. We work with design builder and we got this cooling load with all the necessary our implementations of light cells and all those things. We calculated how much temperature and the set point temperature we had given about 24 degrees. So using design builder, we have come up with this number.
Okay, I didn't see any of those results here, but so I'm assuming you would have done that. These light tubes which you've shown,
yes.
Can you show it on the plan earlier? I think a few slides before this.
This is the plan here. So
Yeah.
we are using it on the light tubes.
Yeah, so this is going up how many floors?
All the floors.
Yeah. All the floors.
8 to 13 on the B block and 8 on the tower 8.
All right. So just one more comment. You presented a slide, I think, on the HVAC system, which I found is very conceptual. I would love to see a little more detail in the drawings in your drawings about how this has been pulled off in the drawing itself. You answered this question on some of this nuances of the system, but it's not visible in the presentation yet. So my advice would be to not just leave it at a conceptual level, dig deeper into it, get the engineering on the drawing as well, and you'll find that there'll be a wide variation. You'll have different challenges there as well. One last comment is, in fact, it's a question as well. If you had an opportunity, do you think a different kind of an HVAC system would have worked better for this building?
So I think Radiant is efficient enough. It's almost efficient, 37% more efficient than a VRF system. And again, this system where we use radiant cooling, it cools the air evenly. So there is no pressurized air from one part of the building which cools the atmosphere. So I think this is an efficient way of cooling.
Did you try some other system, or since you had this project
since we had it already, so we didn't explore any new options because we were asked to do it. So we were like, we'll do something better with this other than trying out something else because it was asked them.
All right, thank you. Thank you.
Thank you. Thank you, jury members. Thank you, Team Gaia. Now let's take a quick 5 minutes and get ready for the next presentation.
jury members ready?
Our fourth presentation is from Team Greenspace. They have worked on an Infosys SDV8 in Hyderabad. The project partner is Infosys Limited. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I'll stop you and ask you to end your presentation. After that, we'll have 10 minutes for a Q&A session. Please keep your answers direct and to the point. Okay team, the stage is yours. All the best. Your time starts now.
Good morning everyone present here. Today, good morning everyone present here, jurors, dignitaries and all the powerful young minds. Today we are gathered here to witness the fusion of the knowledge where ideas are conveyed with precision and persuasion. Myself, Yash Deria, team lead of Team Greenspace from Vivekananda Education Society College of Architecture, Mumbai, along with my teammates Shraddha Shetty, Arya Diwan and Prathamesh Komte, will be presenting you our months of the hard work on Infosys office building, Hyderabad. The world is facing the growing challenge on the environmental hazards such as the electricity and the wastewater generation, emission of the greenhouse gases as well as the waste generation, and the problems faced by the end users, that is stress, lack of communication and problems faced by the working movements. Today we have stand here is all because of these amazing people you see on the screen, our team members and our constant source of motivation, our faculty members. The Greenspace, that name itself specifies the green and the environmental friendly workspace for the employees. A firm grounding platform was provided by our faculty members, which help us to design the best building plans, high performance and the net zero energy office building. Our project partner is Infosys Hyderabad. Infosys is a global technology and consultancy firm founded in 1981 and headquarters at Bangalore. Our site is located at Hyderabad, Telangana, with having a climatic zone composite climate and a site area of approximately 25,000 square meters. The office will be operational from 9 to 5, that is 8 hours. And looking towards the site, this is our site. Towards the west, there is a solar power plant, and the energy to show the net zero energy performance is being restricted. Towards the north, there is a water body, and the site is moderately contoured towards the north. The people which are just a call away for our discussion and all our queries are our industry partners. First one was the V3 Facade Design Studio, which helped us in designing the facade system, as well as it gave us the opportunity to witness the samples of the materials too. And another is a Green Energy Solar Solutions, which help us in calculating the solar energy calculation as well as its designing. Our site is located in Hyderabad, Telangana, and on-site available trees are the Ashoka tree, Sirish tree, white bark and banyan tree, which has been used in our landscape design too. The site is moderately contoured and the sloping towards the north. The soil found is a red sandy soil. Towards the east there is a residential area. Towards the north there is a water body and the Infosys cricket ground. Towards the west I mentioned earlier that it is a solar power plant. Now moving on to the climatic analysis, the highest temperature is in the month of the May, as according to the Hyderabad climate, that is 40 degrees Celsius, and the lowest is 16 degrees Celsius, which is in the month of the December. And Hyderabad having an annual precipitation of 900 mm approximately. The major prevailing wind direction is from the west, which help us to design the central plaza which connect both the buildings in the middle. While the design concept stage, we also did the thermal box models, which gave us the amount of the radiation falling on each of the envelope. So the north receives 300 to 600 kilowatt hour per meter square, and the south having the 1300 to 1500, east and the west 800 to 1000, and the major chunk of the radiation which we found that is from the roof, that is 2000 to 2500. We also did the HSA and the VHA calculation, which helps us to know the chhajja depth in order to tackle the thermal, in order to tackle the direct sun radiations. Over to Shraddha Shetty.
Introducing the bundles of strategies that we have incorporated into our design. Introducing bifacial solar panel for energy generation. Unlike traditional solar panel, bifacial solar panel can harness both reflected and diffused sunlight from the surrounding. When the sunlight strikes on the front side of the panel, the electricity is generated through photoelectric cell, while the sunlight that passes to the panel is reflected to the bottom layer and back to the cells. We have used water from the water body that is present to the north of our site for radiant cooling. It is capable of 30% energy saving as compared to the conventional cooling. Night flush ventilation is used in our building. Night flush ventilation basically allows the cool air to enter inside the building and replace the accumulated heat indoors. We have introduced central atriums that acts in stack ventilation and also provides buffer spaces to the office blocks around. For the facade, we have used the concept of staggering balcony projection that acts as a shading device and lowers the cooling load on the facade. Using low-A glass, which has U value of 0.9, plays a better role in thermal performance. Well, designing a facade plays an integral role coming to office building. So our main motive while designing facade was to keep it playful and fully utilizable by the users. So these staggered balconies provide opportunities for the employees to relax, breathe and interact. It consists of the louvers that cuts off the direct sunlight on the facade. We have introduced light shells. The soffits of the balconies have reflective surfaces. So when the light strikes there, the light shells helps it to travel larger into the indoors. Placing planted boxes on the edges of the balconies that adds the beautification, aesthetic appeal, also noise reduction and improves the air quality there. We have worked on the envelope as such to increase the thermal lag by using XPS insulation and various other materials. Introduce skylights on the roof to inculcate maximum daylight into the building. So when it comes to office buildings, connecting a concrete block to nature seems a little impossible. So we introduced the concept of biophilia into our design. Lack of interaction between the employees and there are various other problems that the user faces. So this green pocket, green wall serves as a cutoff to the office block and gives an opportunity for the employees to interact with each other. The sky codes that are placed at the east and west gives opportunity for the employees to come out, interact with each other. We made sure to maximize natural light as we have larger floor depth, so we have introduced atriums and light wells wherever we could. Retaining site topography becomes important while site planning. So we had a bunch of boulders on our site, so we created a ramp around it that provides access to the main foyer of the south building. It adds to the aesthetic appeal and also adds to the point of sustainability. Our main motive was to create a user experience. So we have provided maximum workspaces and breakout spaces on each floor so that employees can experience a change from working environment and connect to the nature. So we carried out various concept stages. We figured out zoning, circulation through bubble diagrams and form development. Our major focus of design was to design aesthetically pleasing, to create a connection with nature, efficiency and accessibility of every space that we have included, open plan design to foster a collaborative work environment, prioritizing the functionality and user experience. Coming to the master plan of our design, towards the east are the two major entrances. One is the pedestrian entrance that leads to the major interactive zone, that is the central plaza, which acts as a main interactive zone between the two blocks. And the other one is the vehicle and the service access towards the north. While one enters the north, experience a large water body or pleasant zone, which is under this atrium. Both the blocks have 2 lobbies with security check for the upper levels. So planning of the floors have been done informal to formal level wise. We have tried placing offices on the periphery of the plans in order to maximize daylight. Service cores are at east-west. We have kept the vertical circulation of the building in the centers along the atrium. We made sure to have enough interactive and collaborative spaces between the 2 office blocks, which has some openness with the outer surrounding. These are the sections that illustrate the sky courts and the offices internally. The central plaza that plays a major access, and we have tried to connect the landscape with the built structure as much as possible to the ground floor. The form as such gives mutual shading along the blocks of the building. The facade also makes it look more aesthetically appealing and provides a shading device for the alternate floors below. This is the details of the central plaza, the hardscape on softscape. We try to incorporate as much as possible the water bodies in order to maintain the microclimate in the central plaza. And also the south building, that is G+2, shades the central plaza, making it a perfect space for employees to interact. These are the few technical details of the materials and the measures about the facade, the light shell, the planter box and the angled louvers.
To put forth an energy efficient design, we first considered a building model with no specific conditions or materials. So from that we achieved an EPI of 412 kilowatt hour per square meter per year. Then further mentioning the U values and the materials as mentioned in the Telangana ECBC, we arrived at our base case which gave us an EPI of 204 kilowatt hour per square meter per year. The final design case leads us to an EPI of 75 kilowatt hour per square meter per year. The total energy consumption at this EPI is 8,000 megawatts, which is then generated through renewable sources of solar panels and solar trees. In order to achieve the lowest EPI possible, we have worked on various factors such as building form, lighting, envelope, and fenestration. We have achieved U values, the lowest U values possible on the walling assembly, roofing assembly, as well as the window assembly. For the walling assembly, we have achieved at an U value of 0.26. For roofing, we have been able to achieve a U value of 0.32. And for the fenestrations, we have achieved a U value of 0.23 with a window to wall ratio of 30% and SHGC of 0.2 and VLT of 70%. We are using bifacial solar panels with which we are getting 50% more renewable energy generated. Through the solar panels on the rooftop, we are generating 3,000 megawatts of energy, and we are also proposing 500 solar trees around throughout the site with 15% efficiency, which allows us to generate more of 5,000 megawatt of energy, which in total gives us a net zero, which enables the buildings as net zero energy. We are also reducing the energy usage by the appliances by 84% from the base case to the proposed case by using efficient energy fixtures. For the HVAC, we are using radiant cooling. The water which will be used for radiant cooling will be taken from the existing water body on the site, which is the lake. The water will supplied through the pipes will be at a temperature of 14 degrees Celsius, and it will help the structure to remain at the temperature of 28 to 30 degrees Celsius. Coming to the water performance of the building, we have been able to achieve a 52% reduction in the water consumption. To achieve this 52% reduction in the water consumption, we have used various water fixtures, and we have been able to reduce the water consumption from 45 liters per person to 21 liters per person. And also the rainwater harvesting and borewell waters also aid to the use of non-potable purposes like washing, cleaning, flushing, etc. We are also proposing recharge pits, check dams and open pond with aerators on the site to aid to the rainwater harvesting and borewell systems. The total wastewater generated on the site is divided into 43% of grey water and 57% of black water. The grey water generated is 76 kiloliters, which is then treated and used for non-potable purposes like flushing and cleaning, etc. The black water generated on site as well is treated. It is 57 kiloliters, and we are using 36 kiloliters of it for landscaping purposes. And the balance with water which is remaining will be either going to the recharge pits, or it will be passed back to the main source of water, which is the municipal corporation. The wastewater which is generated on site will be going through the membrane bed bioreactor, that is the MBR, and then treated and used for the responsible purposes. Thus, we are reducing the landscaping requirement of water by 50% by the use of xeriscaping. This is an innovative process of landscaping which eradicates the necessity of irrigation and also adds an exotic look to the appearance of the site. This is a closed loop. This diagram proposes a closed loop cycle which we are using in the office. So, which we are using in the office. So this basically shows how the water coming from the municipal corporation is used, treated and reused in the buildings, leaving no wastewater to go away. Coming to the embodied carbon of the building, we have achieved an impressive reduction of 85% in the total embodied carbons in the building. And we have observed that the total carbon emissions which were happening were major factors to those who were the structure, wall, roof and fenestration. So we have tackled those problems by the use of recycled and local materials which are available near our site. And also the major contributors to carbon emissions were aluminium, glass and concrete, for which we are using a recycled steel for the process. We are using low carbon concrete and high efficiency glasses. To make our design resilient in times of calamities, we have a 5.5 days of autonomy for water, and 60% of the appliances are still operable in the times of calamities. We are proposing culinary farming and frozen food storage, and also the organic waste that is generated in the building will be going through an organic waste compost machine and reused for the compost for the culinary farming. These are the main threats which we have identified for the site. This is the fire layout for the building. We've given the refuge floors on the 6th floor of both the buildings. We have provided 4 fire staircases in the G+8 building and 2 in the G+12 building. We have also provided things like fire extinguishers, fire hose, fire balls on all the floors. And during times of fire, the smoke tends to rise up. So we have provided awning windows which can be opened from the top to evacuate the smoke as soon as possible. After the times of calamities, it is also important to recover the building to its original state. So we have provided some measures that could be taken for the recovery for flood and fire. Coming to the health and well-being of the employees in the building, we have, as mentioned by our team member, we have integrated the concept of biophilia inside our building. And plants like these tend to absorb VOCs and also increase the oxygen levels inside the building, thus leading to more productivity and concentrations. We were given a goal of achieving 85% of the area with SDA 100 on 100 threshold, and we have been able to achieve 82.5% area above this threshold. So for the thermal comfort, we simulated the models for the solar radiation, and it proved that the strategy of staggering the balconies resulted in lower heat loads for the lower floors, and thus resulting in adding to the thermal comfort of the building. And we have also provided masking of sound in offices to increase the acoustic capability of the office to the employees. Thank you.
Don't find products for your consumers, but make
don't find consumers for your product, but make products for your consumers. I am here to explain you the part of innovation. First is using IoT-based innovation for presence detection. Whenever the employee enters into the campus, with the help of RFID, his movement will be tracked from building to building and cabin to cabin. Next is xeriscaping. It is earlier explained by one of my friends, so I guess you are very clear with it. I would like to add on that for xeriscaping we will be using plants such as neem, Indian almond and bubble. Next is bifacial solar panels. For bifacial solar panels we will be having the base of mosaic tiles which have the reflective index of 80 to 90%. So it would be a very minor but significant step to including the mosaic tiles. Next is organic waste converter. Now generally in any office building there are two types of waste, non-biodegradable waste and biodegradable waste. Non-biodegradable waste can be again be divided into dry waste and e-waste, and biodegradable waste will only remain as wet waste. Now in dry waste we will have paper materials such as paper and glass which can be recycled, and for e-waste few of the hazardous electronic materials such as computer wires and few of the other electronic equipments which are harmful for human interaction. So it would be sent to a particular authorized area in Telangana. Then for particularly the organic waste converter is used for wet waste. Now whenever we have the wet waste, we can create a compost out of it and we can use it via organic waste converter. Next is affordability. Now radiant cooling for sensible heat through lift. Now we are using radiant cooling. The pipes are passed through the ceilings and walls of the building, and the area is reduced as there is low carbon emission as well as less area for cooling. Next is flat slab structure. The flat slab structure is better than traditional slab and beam structure as it requires very less time and less material for its construction. Next is granite dry cladding. We are specific for granite as it is a locally available rock in the Hyderabad market, and some of the features of granite are it is highly heat resistant, and it is extremely strong and durable and can be reused whenever required. Also we are using AAC blocks. Next is engineering operations. Now the most important part of engineering operations is building management system. It includes various systems such as fire alarm detection, water storage, light control access and CCTV. Next is IoT based attendance. At the entrance we have face detection systems which will make the attendance tracking effortless. We have smart elevators. Whenever any employee wants to go from his regular floor from any other floor, the RFID will be detected and that particular employee will be sent to that particular floor. Next is energy saving daylight sensor. These are the motion sensing lights. Whenever the light tracks the motion of any of the employees or any human, the intensity keeps on varying. Next is value proposition. As our building is located on a prime location, the green environment and the green space within the building is the major attraction for the potential employees. We are including various amenities such as career center, recreational center, and stress relief centers. Now, with increasing amenities, there is a possibility that the energy consumption will increase. So, we are including IoT-based innovation systems and highly efficient HVAC systems. We are also including highly robust security and fire systems to keeping the life on priority. Next is biophilic design. Now, rather than letting go empty space as they are, we are including biophilic design and keeping plants in those empty spaces to keep the environment fresh.
Next slide. We'll just move the slide.
Thank you.
We have also influenced their goals and the design through the social media platforms such as Instagram and the YouTube. Thank you so much. Thank you.
Thank you, Team Green Space. That was a very entertaining and insightful presentation. Now let's hear the jury's comments and take questions from them. Dheeraj, I'll start with you.
Nice way to end the presentation, how you have designed it. I like that concept. Questions, a little different. So no copy paste of previous, if you heard the other ones. Is your project partner using an HFC refrigerant or an HFO refrigerant? That impacts the global warming potential as well. Is your client contributing towards it, or is your client aware of what it will result into? Are you aware of that?
No, sir.
That's fine. This is not a part of the guidance given to you, so I do understand and respect that. We go by it, don't worry. But important point is, it contributes to the environment. Since I see this project partner connecting whatever they are doing to their ESG goals also, so that part also becomes very important. If not, you as responsible designers who are recommending them something should mention over there on this aspect also. Another question, last from my side. What are the 3 things which you learned while working on this project and from your project partner?
One was the
3 different people will answer one.
I learned that the offices I see is a glass box and having the concrete all around. But introducing like this concept will reduce the stress for the employees, and also the interaction interactive areas, recreational areas where one can attend call meetings too. This was from my side.
So one of the most significant things which I got to know is basically we were provided with a particular area named as SLMs, where by the Solar Decathlon India, where we need to go through the videos and study. We went through them, but later on we came to know when we are actually working on the project and including our ideas and brainstorming continuously, then we came to know that hands-on working is most important rather than just theoretically working or any project. Thank you.
One thing that I learned from this process was the importance of teamwork, and also that the normal HVAC systems that we see in the offices, the amount of effect that they are having on the environment is going unseen by most of the companies. And so the necessity for going towards a net zero building, that is what was highlighted to me in this process.
Thank you. This is a learning process. It's important for us to also ask, what did you learn? Thank you.
Okay. Hi. Good presentation. 2 kind of related questions related to cooling. Okay. In one of your first slides, you have also said that your design has included something on stack ventilation and night flushing, and then you have an HVAC radiant cooling thing. So when are you using stack ventilation? Night flushing as a name suggests night mein kar rahe, okay? When are you using stack ventilation, or where are you using stack ventilation, and when and where are you using the radiant cooling? I mean, how do these 2 things kind of work in your building? So that is the first question, if you can.
So we while working on the design builder model, we specified the zones of the working spaces for the offices as condition, and the parallel corridors which are present in the office building, those are non-conditioned areas. So stack ventilation will be happening over there, and radiant cooling will be workable for the office area.
So it's more of a spatial difference that you're doing. And night flushing is for what? Night flushing is also only for the non-conditioned areas, or for
it is for both, as using night flushing in the conditioned spaces will reduce the condition load for the next day as well.
Okay. Is there a condensation thing? I don't know. Later probably we can talk about it. The second question was, you also said radiant cooling lake water you are using.
Yes.
In what phase of that radiant cooling thing are you using? Where are you using the lake water?
the water which is to be circulated in the pipes for radiant cooling, that will be taken from the lake. We have also provided the exact amount of water which will be required, and it will be a closed loop. So once the water is taken from the lake, it will be purified and used in the pipes. By the help of chillers, we are reducing the temperature of the water and circulating it throughout the structure to help with radiant cooling.
So it's a one-time thing that you one time
Yes.
to take the lake water and then it is there in the
Yes.
pipe. That is what you are doing.
But we are proposing the water from the lake because the amount of water which is required to cool both those buildings is a lot. So it will affect the water efficiency of our building in the future.
Alright.
Sorry, that actually brings me to a question, since you answered that.
Yes.
This is being used for radiant cooling. So that means you are discharging the hot water to the lake and getting the fresh water again into the radiant pipe. Is that?
That is not like we are also proposing some. We did not add those to our presentation, but we are also proposing some fountains in the lake, which will cool the lake water as well. So if the water is discharged to the lake, again the water of the lake will be maintained at a certain temperature to be used again for radiant cooling.
Yeah, that's the reason I asked that question.
Yes.
So a little more on that lake water.
Yes.
So what results in the reduction of 30% of energy because of lake water?
Because of the lake water.
Water uses the energy.
It does not affect the energy as such, but
So
it
your
affects
slide
the
shows
water
30%.
efficiency.
Your slide shows 30% energy reduction because of use of the lake water. I don't know which slide number, but I saw that in one of the initial slides.
There might be a mistake from our side because 30% reduction can be happening because of radiant cooling, but lake water is majorly affecting the water efficiency of our building. So that we do not require any extra water for the purpose.
Yeah, so you're still using the lake water.
Yes.
You're still using water for cooling the projector.
Yes.
So all that is still the same thing. Another comment I have, observation. Can you go back to slide 20? Yeah, slide 20. Next one.
This one?
20. So I wanted to look at these numbers and bi-layered solar panels 1248 megawatts, solar trees 5100 megawatts. Are you sure about these numbers?
Yes.
Yes, so we have calculated that also.
I would suggest that you look at these numbers. These are mega numbers. They're megawatts. I would suggest there must be something wrong in your units. Look at these numbers, right? Dig deep into it. I'm sure you'll figure out this. These are big numbers, really big numbers. So I'd suggest that you look at these in more detail. Yeah?
Yes, sir. Yeah.
Anyway, thanks for the presentation. You put all of this together. You've not just taken your the brief from your client as a copy paste. You've done some work on it. I appreciate that.
Thank you so much. Thank you so much, sir.
Thank you.
Thank you, jury members. Thank you, Team Greenspace. We will now be taking a long lunch break. We will start the presentation for courses at 2:30 p.m. Folks online, I request you to tune back to this channel and be ready for the presentations of the upcoming teams. Thank you. Hello everyone, welcome back to Office Building Division. We will now continue with our presentations. Our fifth presentation today is from Team Poesis. They have worked on Infosys Hyderabad office. The project partner is Infosys Limited. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a signal like this. You won't have the 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentations. After that, we will have 10 minutes for a Q&A sessions. Please keep your answers to the jury members direct and to the point. Okay team, the stage is yours.
Good afternoon, one and all present here. We are extremely grateful to have an opportunity to design a net zero office building, and we would like to thank our judges and the faculty members for their valuable feedback. We Team Poesis are a group of 7 students from Impact School of Architecture and PES Mandya. So we will be taking you through an integrated design process of how we achieve a net zero office building. So our site is located in Pocharam village, Hyderabad. It is a part of an existing campus being developed in phase 3. The site area is 65 acres and the proposed built-up area is 94,700 square meters. The climate is an hot and dry climate. So in the master plan, we have an approach from the east adjacent road, approaches to 2 distinct buildings with G+8 and G+11. And we have strategically placed STP and waste management system towards the north, which is at a lower elevation than the buildings, which helps to reduce energy consumption while transporting the sewage waste. In this hot and dry climatic conditions, cooling and dehumidification are considered essential. But through initial design analysis, we have come to that using natural ventilation and elevated ASP, we can reduce the number of cooling days required and adapting passive design strategies. Considering IMF 90% accessibility, we have come to a conclusion of using 0.7 meter per second elevated speed to achieve 100% comfort hours. The concept has derived through detailed analysis of the site counters and the climatic condition. We have sculpted the buildings towards the south to maximize solar energy generation, and the compact volume creates a central courtyard. And the buildings are oriented towards north-south to maximize daylight and reduce solar heat gain. We have achieved a daylight of 59.5% with 2 credits for heat. Through the solar radiation analysis, we can verify that there is very minimal direct radiation on the walls. So we have a building 1 with built-up area of 43,300 square meters and building 2 with 51,400 square meters. And these are the distribution of ODC of 100, 50 and 200 seaters with mixed and conditioned areas. So we have placed 200 seater ODC towards the north and 150 ODCs towards the south, which is the receding part. We have residential spaces, cafeterias in each floor with food courts in level 3, 5, 8 and 11 in the alternative buildings, and a central service core on each floor. These are the views of the ODC and the cafeteria.
For comfort, we have designed our building with a raised floor system with an radiant cooling system. This not only provides a sturdy foundation, but it also effectively lowers the floor surface temperature. We have given planter partition boxes with storage spaces, which brings in a touch of nature into the built environment while improving air and acoustic properties. It also serves as a natural divider. Balconies are designed with a double skin facade, which helps in the radiation of heat gain. materials. We have considered U values of different materials so that the wall sections, the total U value would be low, which results in the reduction of heat gain of the building. Through the use of passive design measures and energy efficient electrical appliances, we have achieved an EPI of 56, which is lesser than the target EPI which was given to us by the project partner of 65. Solar potential. In solar potential, the total energy consumption of the building has been achieved completely through solar panels, through the use of monocrystalline solar panels, which has an efficiency of 20%. The total installed capacity of solar panels is 3.1 megawatt. The first graph shows the annual energy consumption, showing the energy use over the months. The total energy generated on site is more than that of the requirement consumption of energy. There is a key plan showing the distribution of different sectors from where the solar panels are providing it energy for lighting, equipments and HVAC use. Efficient lighting and equipments have been used, so it contributes lesser towards the electrical loads. The total equipment loads of the building are coming around 18,85,000 kilowatt hours and the lighting load being 13,68,000 kilowatt hours. HVAC, the first graph shows you the standard HVAC design versus our proposed radial cooling system. It has a cooling load of 18,60,000 kilowatt hour, and here is the exploded view of the radial cooling system. We have designed a dynamic facade for our buildings, wherein it has two light sensors, and it determines the position of sun and opens the window panels such that it reduces glare and heat gain of the building. I will show you working of it. We have developed a prototype wherein upon heat gain, the solar panels are controlled such that the glare is reduced. You can see the when light is it's taking light how much, and it calculates how much window should be open. We have also developed an app called Info1. It's basically an IBMS system which monitors the lighting, HVAC loads, the productivity management, security management, and also a health tracker. Basically, each ODCs and working areas will have sensors which are being monitored real time, and it will give us real time data on which team how much energy they have been consumed, and healthy competition would be put out so that they can also contribute to reduction of heat gains.
For water, we have used an efficiency water cycle that ensures the grey water and the fire safety to efficiently use and reuse the water to its maximum position to go to the sewage treatment plant. With the help of waterless urinary and water efficiency fixture, we have reduced the water consumed by 55.5 from the base scenario of 45 liter per capita per day to 20 liter per day per capita per day. We have incorporated a network of underground tank, water treatment tank and fresh water tank. They send their respective water to respected buildings. Grey water is filtered with the use of green plants with deep root system. Rainwater from the solar panels and terrace pass through vortex filter and goes to ultrafiltration filter, and then further purified with the help of UV rays and active charcoal and chlorine to make it potable water. Black water system. Black water is passed through sedimentary channel and anaerobic channel and filter medium, after which the treated water is collected and solid waste is composed to manure. The RCC frame structure is designed according to IS 456 and the ETAP analysis is done to check the stability of the building. The east facade of the building features the green wall, creating ambient pressure that ensures the connectivity with nature. The layout shows the distribution of the cooling system. Green represents the mixed mode, blue represents the conditional mode. This is a detail of the radial cooling system. This is the plumbing layout and the section of balcony.
The IBMS is integrated with different subsystems within a building, such as ventilation, air conditioning, lighting, security, fire alarms, and other building systems, which provides a unified interface and control platform, allowing facility managers to monitor and control these systems from a single point. The building is designed by following the fire safety guidelines by NBC. The region falls in the Zone 2 structure is designed according to the IS 456. The roof and wall sections with low U values are used to reduce heat gain inside the building. In case of grid disruptions and blackout, solar power backups has been provided. On-site STP has been provided to treat 100% effluents with zero discharge. For social resilience, breakout space and green balconies has been given. Active and passive fire safety measures have been considered. The plan shows the fire escape layout and emergency exits. In case of emergency, a recovery plan has been considered, which involves in 4 stages: providing emergency services, examining damage and providing solutions, conducting repairs and restoration, evaluating lessons learned and updating recovery plan. We have also considered a waste management system, which involves segregation of the waste into 6 types. A dedicated storage space is provided for this on the site. The organic waste is put in composting units and the waste is sent to nearby recycling and disposal agencies. A reduction of 7.35% has been achieved in embodied carbon compared to base case. Carbon neutrality can be achieved within 3 years by offsetting the building embodies through solar power generation and planting. The total project cost is 226 crore, which is 7% higher than the baseline cost, but the total operation cost is much lesser than the baseline project. This has been achieved by improving the building performance through various strategies. The life cycle costing of HVAC system for 10 years reduces by 30 lakhs by using radiant cooling instead of VRF system. Solar power plant achieves payback period in 3 years. By keeping this proposal as a prototype and with minimal changes as per the requirement, this building can be adapted to suit needs of users in similar climatic conditions and scale irrespective of its typology due to open floor plan proposal. The dynamic panels can be used for buildings which offer double skin facade for reducing glare and heat gain. The dimension and panel design is customizable according to the user. The potential market for the dynamic panel system ranges from medium-sized enterprises to large-scale buildings.
So, to promote the design, we have conducted a seminar in the college and invited guests from outside to have a feedback on the design. And to summarize, so we have incorporated overhead tanks with black water, grey water, and rainwater treatments. And in the design, we have a raised floor system, green wall, balconies to reduce the heat gain, parametric facade credits with creepers, and through this we are able to achieve a balance between form and the function. We have an active fire safety system, fire exits, and refuge area recreation spaces in each floor with bridges and alternative floors to connect the building. We have achieved 100% comfortable hours through passive and active cooling, and a daylight of 59.5%. Thank you.
Thank you, Team Poises. You finished well in time and a very good job on your presentation. Let's hear the jury's comments and take questions from them. Samita, I'll start with you.
Thanks team for the presentation. You had a slide on the HVAC system. If you could pull that slide up and take me through very quickly what your concept is. You have underfloor, you have radiant, you have mixed mode. How does this all operate together?
So we have used a raised floor system and we have AM cooling. So due to raised floor system, we have the air coming from the bottom of the floor. So the air gets cooled from the radius system. And
which air are you supplying from the bottom of the system, from the underfloor?
Yes.
Which air are you supplying from the underfloor?
So
are you using air also to cool the system or just radiant?
So we have AM cooling system and air. So the when the air passes touching the AM cooling system, it gets cooled and it goes up. So through this, what happens is the energy required to remove the hot air reduces as because we have exhaust outlets on in the ceiling. So you don't need energy for that, and it is more comfortable having cooling at the bottom.
What brings the air in? What air is? I'm not seeing any equipment here which brings air into the underfloor.
So we can see ducts below the flooring over here. So they pass.
So where do the ducts come from?
So we have ducts through the shafts coming to air. So we have an AHU window at the top which circulates air.
So is that a fresh air which is coming to the
Yes.
building? Is that underfloor or above floor?
Fresh air comes through underfloor and it gets cooled through radiant cooling.
Okay. So, I said one more observation inquiry. Actually, you've done a nice job of developing something, going beyond just googling for something and develop dynamic side. To scale this up to a building, what kind of challenges do you anticipate? Can I take this and scale it up and then basically do a building, or do you think there's a challenge here?
So the challenges are like the old buildings. If you want to retrofit it, it's really retrofitable to other buildings. So who don't have so by doing this to other buildings, it reduces their HVAC cooling loads. The challenge over here is that to promote it and make people aware, because from many years they are using those buildings. So the main challenge is to promote and make them to convince them that this is feasible over.
So my query is more technical. If I take this, make this larger 10 times, what will be different in the system?
I can understand that.
Just if I scale this up 10 times, this prototype which you have done, what will be different in the system? What kind of challenges do you think? Technically, I'm saying.
So to use the system, so it can be operated in two ways. One is like you have the weather data already, like the EPW files through that, or you can have a locally weather station. So it measures the real-time sunlight and changes. So it depends on how the client wants it.
No, so okay, I was talking more technically. So I'll try to give a more guided thing. So there is some sort of energy consumed for driving these. What will happen when you make it 10 times bigger, 50 times?
We are not able to calculate that. But in our design, we have given a miscellaneous EPI of 2, which will compensate, and even considering that, we are achieving a net zero.
Right. So work on it a little bit more. It's a great idea. There is applications in India. Work on it a little bit more. I think it's a good job here. Otherwise, thank you.
Thank you. Hi. So my question is again on that really, because in one of the slides you mentioned that this is 35,000 per panel. Is it?
Yes.
So 35,000 per panel. What is the size of the panel?
3 by 3. But it is customizable. Like the panels now we have modeled of a solid one, but we can have patterns in that, so it allows some light. So it is totally customizable.
So you said 3 by 3, is it?
3 meters by 3 meters.
So this comes around how much? How much per meter square? 4,000 per meter square, is it? Okay.
Have you estimated the cost of it?
That's well, 4,000 per meter square is not too high, but it's not very low either. I mean, that is the thing. And you would need to have light sensors or something, some kind of sensor there to.
We don't need sensors for each panel. We can have a couple of sensors around the facade of the building, and it works.
Okay, all right. The one thing which I'll point out here, but I think it is applicable to many other teams also, is that in your embodied carbon thing, what is the base case that you have taken? What is the proposed case that you have taken? And when I say base case, I mean base case, what materials are you really talking about? And proposed case, I can imagine that what you had given in the energy side also, because you had AAC plus XPS, some kind of thing like that. But what is the basis that you have taken for the embodied carbon calculations is usually not very clear to us. Can you just, if you know it, can you tell me what is the basis?
Bricks instead of AAC block.
Instead of AAC block, right? Now the thing is that in your proposed case, you have also used XPS. So did you consider that?
Yes. In base case, we had not considered the amount of insulation needed as much as the proposed case.
So where, how is your, you said you have a reduction of how much percentage on embodied carbon?
7%.
7%. What is the biggest contributor in the reduction?
Ma'am, it is the AAC blocks, because the number of blocks required is also very less because of the size. It's 600 by 200, whereas a normal brick is 100 by 200.
It's only because of the AAC blocks.
AAC blocks and the elevation facade. So we had considered normal windows over there. So we need more aluminum frame over there. But here we are using glass wall. So it is just fixed to point supports.
Okay. And what about because you're using AAC? Did you also look at if your structure becomes lighter?
Yes.
How much did you calculate that?
So per square meter, the weight of the bricks is 600 kgs, while per square meter weight of the blocks is only like 40. Per square meter in the base case the weight is around 1600 kilos, while the AC blocks is only 400.
You should have. This is on affordability. What I am saying is that when you use AAC blocks, the amount of concrete and steel that you would need will also reduce, and I'm not sure whether that is in the 7.5% reduction. Is it because of that or not? But that is something you need to consider.
I think we do not consider.
Right. So just one person answering. That's it. Don't want to? No worries. You can take a decision who answers. A few observations, and I will continue with the comments which I had shared. This is your deliverables in the last part. I observed that there was no calculation on dehumidified CFM to calculate the load.
Yes.
Would you like to comment on that?
Actually, we couldn't do it the right way, so we did not input that.
Just ensure, whenever you have to calculate the load, which is the very essence of what you are going to put as a system, and energy consumption. Energy guzzler is the air conditioning system inside any building. It consumes close to 40, 50% of the energy roughly. So it's very important that you work on it. Otherwise, you will not get to the right base. What is the energy consumed versus any system? So that's important. You cannot have only the tonnage to be defined or kilowatt to be defined as what the cooling load is. Dehumidified CFM is the right measure, basis which you convert that into tonnage, and then you decide what is it that you want. And then you take calls on safety and what load diversity you will consider in the application. That's how it works. So it's not important that we do the project and achieve what we achieve, but we also learn in the process is also very important. So I'm just trying to help you so that you make sure that the good work which you have done, small little things, they are very critical. They can make you move in a new direction. So that's one. I also observed that you had mentioned COP in your report. Again, I mentioned this in the deliverable also the last one. You mentioned that is 3.
Yes.
Is that right?
No, I think it was too low.
3 COP is low even for the air-cooled system. That's why I asked that question.
Yes.
You are using a water-cooled system with an MT and an LT chiller. So your COP should go up beyond 7. If you ask me, today technology gives you that. Third question is again, I continue on deliverables. I saw your chiller placed on rooftop in the drawing.
Yes.
It is placed on the rooftop, you are saying?
Yes.
This is a water-cooled system, are you sure?
Yes.
Okay. Is the client allowing you?
No, we did not confirm that.
Water-cooled systems in 99 cases out of 100 are placed in the
Basement or ground floor.
Yeah. You will find very few cases unless you don't have space in the basement, then you take it to the rooftop because they create a lot of noise and vibration. It impacts the people working in the office. So just make sure that you are able to get that clarity and ensure that what is the right thing. It can be done. And that's why I wanted to know. It can be done. Okay. So whatever you propose, make sure that you've got enough reasons to back it up. So these are few things which I wanted you to pick up as learnings, and that's why I asked these questions. I wanted to make sure that you are covering them all. That's all I think from a project proposal perspective, from a working, what I understand from others also that your project partner had given you some guidance to adhere to.
Yes.
So in one of the presentations, Samit mentioned, and I echo his words, that please also apply your own mind to see are there alternative solutions. And can they be better? Put forward to your project partner for him to evaluate and then take a decision which is right. Whatever it is. It can not only energy, water, energy, design, everything all put together. Apply your mind as well. That's what this competition is all about. Thank you. Good work done and appreciate the work and hard work which you all did. Yeah, this is something which we appreciate. This is different. And certainly gives us an insight as to what you are talking about. Thank you.
Thank you.
Is this developed by you or project partner?
Alright, good job Team Voices. Thank you jury members, thank you Team Voices. Let's take a couple of minutes to get ready for the next presentation. That is Team Titans. Alright. So our sixth presentation is from Team Titans. They have worked on AgroCard headquarters corporate office in Bengaluru. Their project partner is AgroCorp Land-Based Private Limited. So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have the 21st minute, which means at 20 minutes, I'll have to stop you. and ask you to end your presentation. After that, we'll have Q&A sessions with the jury members for about 10 minutes. And you have to keep your answers direct and to the point. Okay. So team, the stage is yours. All the best.
So,
your time starts now.
A very good afternoon. A very good afternoon to everyone present here. We are team Titans from National Institute of Technology, Tiruchirappalli. We have worked on a project, Agrocorp Headquarters Corporate Office Building, which is located in Bangalore. We are a team of 12 members, which is inclusive of 10 architects, 1 civil engineering and 1 energy engineer. And today's presentation will be done by Ronitatis, Arunachidam, Pavitra and Nishant. We would like to express our gratitude towards our institute, to our faculty guide, Professor Ramdan sir, our industry partner, Mr. Rakesh Bhatia sir, CEO Vice President of Tata EcoFirst, and our project partner, Agrocorp. Over to you.
Good evening, everyone. Thank you, Ronnie. So, I would like to start from our design process, how we started our design. So, where we started, we just had a discussion with our guide, with our faculty guide and our project partner and industrial partner, and we came up with the requirements for this project. After that, we get into this particular stage, strategies to achieve our net zero target. So these are other strategies we have achieved. So our site area is 4,097 square meters, and which is the permissible FAR of 32, and which is in Bangalore. This is our site. So the proposed built-up area is 4,615 meters square. So this is our site context, which includes it abuts a 30-meter wide road in front of this in front of our site, and there is a lake in between behind our site, which is 150 meters from the site, and there is a railway station which is 65 meters from our site. There are potential risk of this noise thing. So, and within the site we have the Ashoka trees and the coconut trees, and there is an existing water pond within our site. So, we analyzed our site with various simulation like radiation and shadow analysis. We come up to we get to this strengths and weaknesses of our site. From I just want to talk about this weakness because the weakness of this site, we have a site which is very narrow, and we can't much play with the orientation. The given orientation of our site is northeast and southwest. Southeast. So what happens is the site is very linear, which becomes our threat. Yeah. So to address these issues, we come up with a concept which is living staircase. The primary thing we get to into our mind before designing this thing is we are designing net zero building, but we just have to have an eye on users' comfort, which is very essential. But our concept itself starting from it only, because this living staircase characteristics of this living staircase is it's made up of natural materials like stone and wood for the railings. So this helps in various aspects of our design, which is energy, function and connectivity, health and well-being, resilience. So how our concept helps in achieving our net zero targets. So energy performance. This particular staircase is positioned on the left side, on the southern eastern side of our building, which gives a buffer for annual solar exposure to the sun from the southeast side, and also helps in achieving daylight inside the building. So in the function and connectivity, in the zoning, if you see the staircase is Staircases will be our center core, which connecting all the parts of the building. So, for the form development, it started from the staircase alone. So, in the southern eastern side, as I mentioned before, we have this atrium kind of space initially, but later we have added this staircase to achieve more dilating. And in the zoning, so we zoned the building in such a way to achieve public spaces, semi-public places, and private spaces, so that we can reduce this movement to the top floor, which plays a major role in this energy consumption. So in the ground floor, in the basement, we have our car parking. Ground floor has a reception lobby and vendors meeting, which are public spaces. And for G+1 and G+2, we have our workstations and our recreational area. And the third floor, which has executive rooms, which is private. Only few number of people is going to access that place. So next slide. Over to Pavitra.
Thank you. So according to Bangalore's DCR, minimum setback of 4 meter has to be provided in all sites for a building of height 15 meter. But a site is very linear. To facilitate the fire tending movement, we have increased the setback of the western side from 4 meter to 6 meter. We have designed bicycle, motorcycle and car parking in the front, and we have retained the existing pond in the back side of our site for water management purpose. The rectangular block is separated into good amount of solids and voids to facilitate the daylighting into the interior spaces. The service core is provided in the center of the block, which connects all the zones vertically. The building consists of solar panel in the terrace with an elevated height of 3 meter to facilitate the movement of human. Algae panels are provided on the eastern facade for increased energy efficiency and aesthetic design. The building shell is made up of hollow clay block as it has property to reduce the dead load, and it has U value which helps in less U value which helps in optimizing indoor thermal comfort. In the interior spaces, we have used agri-bio panels for partitions. It has a sound transmission class of 40 decibels, which will enhance the indoor acoustic comfort. We have used expanded metal sheet on the front facade for the purpose of providing daylighting and shading together. Over to Nisha.
Thank you, Pavitra. In building's energy performance, we have achieved the best case EPA of 43.69 kilowatt hour per meter square per year, and the EPA reduction is 61.63 we have achieved. For this, we have used the passive and active strategies. Some of them are optimized cell composition, night flush. These are the passive strategies, and efficient HVAC system, reducing the LPD and EPD, algae bioreactor panels. These are the active strategies we have used, and we have renewable energy system which can produce 2,17,500 kilowatt hours per year through 145 kilowatt peak extended canopy. Okay. We have followed the approach of reducing the loads and further counterbalancing to make it more energy efficient. For that, we were calculated the ETTV and RTTV values. As per the IGBC benchmarks, we were able to achieve ETTV and RTTV close to 40 in the case 3 and 2. And when moving to the daylight for the efficient fenestration and achieving the lighting levels of 300 lux as per NBC, we have carried out ASC and SDA. In this, we could able to meet the requirements in the case of 3. These are the wall, roof and glass assemblies used for the design case, which help us reducing the heat ingress due to the lower U values. Next slide. In Bangalore, the climate analysis shows only 17.5% of the total occupancy hours throughout the year has to be conditioned, and moreover we are using night flush to make the building pretty cold. So the HVAC system proposed for this is a VAV system with air-cooled chillers, standalone ERV, and air handling unit with air-side economizer. The COP of the system is 6. Next. This system is powered through the grid, and the renewable energy system, which is an extended canopy, it is connected to the grid through net metering. It is connected through net meter in order to reduce the maintenance costs and huge investment over the batteries. The spaces are equipped with occupancy sensor, thermal and CO2 daylight sensors, automated windows for the night flush, which makes the whole building system efficient. Therefore, we can see 61.6% reduction from the base case to the proposed case, with excess generation of 18% of energy. Hence, by using the mentioned strategies, we were able to become net positive.
So, in water performance, we were able to achieve a water reduction of 68.3% by using the strategies such as polishing pond for rainwater and collection. We reduced low flow. We have used low flow fixtures for reduction of water requirements. We have used vortex dewatch system for with an efficiency of 90% for an increased water treatment. A disinfection tank has been used, and 80% effective drip irrigation system has been used for the landscape irrigation, and a bioswale has been used throughout the length of the site to capture the rainwater, and the aeroponic system has been used to reduce the water requirement in the rooftop gardening. So, like the base case water requirement, we calculated to be around 5,813 kiloliter per year, and the proposed system is around 1,845 kiloliter per year. So, from this water schematics, we can find out like our main source of water for the site is like through rainwater. We are getting zero water from the municipality. However, due to resilient factors, we are having our borewell option as an open, so that like in case of resilient factors, we will be able to recharge borewell. And we have oversized our underground and overhead water tank, so that even in case of there is water scarcity in the rainy months, we'll be able to use the water which is stored from the previous month. And we have, by using these strategies, we have decreased our LPCD from 45 liter per capita per day to 15.3 liter per capita per day. So we have used a vortex dewatch system for our water treatment, which recycles around 5.5 kiloliter per day, with acts with an efficiency of 90%. And by using these strategies, we were able to reduce around 68.3% of water from the proposed to from the base case to the proposed case.
We have not compromised on the user comforts while designing a net zero building. The building is a barrier-free environment by providing ramp, elevator, guiding rails, and toilets for differently abled with wheelchair access. To achieve user comfort, the workstations are in accordance with anthropometry and ergonomics is ensured. Lighting with color rendering index more than 90 with reduced flicker rate has been used. The 40-meter frontage in the site acts as a buffer for reducing noise and air pollution. The materials which we have used in the project are with less VOC, less mercury and lead content. The living staircase acts as a social corridor. A crush is being provided in the ground floor to facilitate the toddlers of the employees working in the office. The entire premise is a smoke-free zone. Live monitoring of CO2, particulate matter, PM2.5 and PM10 is provided. Air purifiers are added in lobby spaces. Further, we have added algae panels and indoor plants to absorb CO2 and healthier ambience. Coming to resilience factors, we have identified the threats, and to counteract the following strategies is being implemented. A good frontage and existing trees is being retained in the site to address air and noise pollution. Electronic vehicle charging point is given in the parking for future technological changes. Aeroponics is used in the terrace for food resilience. Bangalore comes under zone 2 of seismic zones. Then even the earthquake codes of IS 4326 and IS 1893 have been considered. A good structural strength is being ensured to address the wind hazard and cyclone hazard. Bangalore is facing a lot of power cut issues. So peak load requirement is 121 watt hour. So an 18,150 volt ampere inverter is provided in the electrical room. Living staircase acts as a fire exit. The underground sumps and overhead tanks are right sized to achieve the days of autonomy. According to realized standards, which is the resilience standards, 4 days of autonomy has to be reached for office building. We have reached 5 days of autonomy. Over to Ronnie.
So our materials that we used are not only healthy for the occupants but also for our environment. We have reached a carbon reduction of 40.23%, in which the wall contributes towards reduction of 97.14%, the floor reduction of 0.99% in floor, an increase of 16.6% in roof because we use fluid roof tiles in order to reduce the heat ingress through the roof, and a reduction of 48.7% through the fenestration, and a reduction of 18.3% through the structures. By using this optimized material, we were able to reduce our carbon emission by 2,337.4 metric ton, which is equivalent to the carbon sequestered by 2,787 acres of forest in a year. So, the optimized structural system consists of AAC filler slab, hollow clay blocks as an exterior wall material, agrobio panels as an interior wall material, and usage of recycled aggregate concrete, which is of 20% of salvaged RCC. Black water, sludge, and organic waste has been treated into a compost plant which is provided in the site. Domestic hazard waste has been sent to municipal incineration plant, and all the recyclable waste has been sent to an approved recycler from the municipal. Algae biopanels work under the principle of they take in sunlight, nutrients, and CO2 from the environment, and they give out algae biomass, oxygen, and nitrogen. The algal biomass is further sold to an exterior industry, so that we'll be able to generate revenue through that. And aeroponics shower garden has been used in the roof. It works under the principle of air or misted sprayed water are used for an aeroponic system. By using the system, we have reduced the water consumption for our urban gardening, and by using this, we have generated a yield of production of 11.5 kg per square meter per yield for tomatoes. Our life cycle cost reduction has been done through usage of recycled concrete in place of conventional concrete. Additional electricity has been sent to the grid to generate revenue, and aeroponic system creates a large amount of revenue through our gardening system, and porotherm blocks instead of conventional bricks, which reduces the cost, and the usage of energy efficient materials and strategies will be used to achieve a payback period. And installing fire retardant system, since our building is very less, the space between two fire retardant systems is less, we have not opted for a sprinkler system, by which we are able to achieve a payback period of 6 years. The project benefits the project partner by reducing the life cycle cost of the building, the builders by introducing new eco-friendly materials and technologies, the occupants by providing them better experience, lifestyle, productivity, and well-being. The project economical, environmental, and social factors have been addressed through human-centric biophilic design, construction, operation, renewable energy, and innovation. So these are the major impact points that we have used in our design. Yes. Thank you.
Thank you, team. You did a great job. Now let's hear from the jury members. and take questions from them. So now I'll start with Sashwati.
Hello. Okay. When you your embodied carbon or your carbon, I did not see the word embodied there. So your carbon reduction is basically happening. You are saying due to walls.
We have reduced it through walls, fenestration, roof, floors, and our structures.
Right. Now, the most that I see is wall. Okay, you're using hollow brick in comparison to what? What is your base case here?
Our base case is AAC blocks.
And you're saying that even in comparison to AAC block, hollow brick is less?
Yes, ma'am.
Okay, that I mean both of them are quite low in comparison to bricks, but that is something we can check again. Fenestration, how do you reduce?
So we have used double DG units in the east, but when we are providing algae panels, in those places we have used single glazing units because like the heat which is going to get transmitted inside the building will be less through our algae panels and our single glaze unit. And we have used double glaze unit only in the southern facade, and other places we have used single glaze unit with efficient materials, and also like we have got the local producers to give us, which reduces the carbon from the transport. And
again, what was the base? What was the glass that you used in your base?
Single glaze unit.
Single glaze. Now, one question which comes to my mind, because you said carbon savings, so is it embodied carbon savings or total carbon savings that you are talking about here?
Embodied carbon.
Embodied carbon. Okay. Again, I don't know how the calculation works, because if your base case was single glass, then single, and then here you are using single plus algae or double glaze. So there is something to, I mean, that also needs to be checked a little bit. Other question is, you have in one of the slides you mentioned recycled concrete. What do you mean by recycled concrete?
So we have used demolished concrete materials with 20% of this demolished concrete materials in our structural concrete, which will reduce the amount of freshly generated concrete will be
you
using.
have a civil engineer in your
yes.
Because again the whole thing of whether it is it is code compliant or not.
Yes, it is code compliant.
Of that sort. Where do you get your recycled concrete from?
So we have identified spots nearby the site, which the distance is very nearby, so that the carbon doesn't go up due to transportation. So we identified some demolition site present, which will be
two small questions.
Yes.
ETTV, RTTV full forms.
Envelope thermal transmittance value and roof thermal transmittance value.
Okay. Again, as someone mentioned in this thing earlier, other people may not know that. And the last question, I think, which again, because both sides are mechanical engineers with me. So you mentioned air-based mechanical cooling system. Okay,
yes.
That is what you are doing.
Yes.
How did you arrive at that decision?
Okay.
I mean, that was my last question. How did you come to the fact that an air-cooled mechanical system?
So we didn't want to increase our water performance because of the HVAC system, because if you're using a water-based HVAC system, it requires water throughout the year, which will shoot up the water requirement. Yes, ma'am. We wanted to achieve a water positive design, so we had that in mind.
Good. So you took away the question I had in my mind. But before I ask my questions, I will take maybe a minute, and which I hope you allow me to. I would like to appreciate the project guides who have associated their team and come over here. I acknowledge your presence and the motivation it gives the team. Certainly would like to have more of you. This team, I observed the previous team purchase also, we have the project guide with us. So certainly it gives a lot of motivation to our team. I would like to acknowledge this one. Other than that, from aspect of design, since You have worked so extensively. What I would like to praise are two important things. Okay, what I observed with you is, while you are designing a building, you are taking care of the indoor air quality. You spoke about it, and you have picked up standards. You know the standard which you have picked up. That's a unique standard, and the only standard which includes air quality in it. No other standard till date has roped in the air quality also in it. Rest all talk about water and air conditioning, energy, etc. But air quality, the first ones. Continue doing this good work. Whatever project you work on today, tomorrow, and years, please do ensure that you work on those lines. This is something which is admirable, and I would like to ask all the architects sitting here, all the team members sitting here, to please incorporate that in your design, whatever work you do in future. So that's a very good thing which you have done. Third, what I picked up was, you picked up your SWOT analysis you did. From there you picked up what's the weakness, and you try to turn it around into a strength. That's something which is admirable. The only area wherein I felt probably there has to be something in it is, you mentioned, sorry, I forgot her name.
Arunachal.
Okay. Arunachal, you mentioned that the coefficient of performance of your system, she touched upon it, the air-cooled system is what you are choosing.
He mentioned that. Yeah, it's me.
Sorry. You said that you achieved 6.
Yes.
6 in an air-cooled system is amazing. I would like to learn. Trust me, I would like to learn how did you do it. If it is, even if it is part load value, COP is full load also and part load also. If it is even the part load values, I would like to learn. Full load nobody has achieved. There is only one system in the world which has touched close to 6. I don't want to do any brand selling over here for somebody. There is one brand which has got air-cooled system which is touching 6 as COP as full load. So it's amazing work which you have done, and I trust you on face value, but do let me know how did you achieve it. That's all from my side. Sure. Thank you.
Thank you, sir.
Thanks, team, for the presentation. Just my observation of the work you've done. I think there are a lot of technologies that touched on algal biopanel, aeroponics, a bunch of things which you have touched on. What I really love to have seen is a little more digging deep into it. And I think I keep telling this everywhere, but for example, you've taken algal biopanels that will reduce the heat gain, but that will also bring down the daylight. So what is the impact of it? Is it better or worse? Right? And how do you sell your, this to a project partner? You're asking to buy an algal biopanel, it's going to cost you money. And from what you presented, you get the benefit of it when you take the biomass outside the site and you sell it, right?
Yes.
Why will a project partner invest in something which is not benefiting directly?
Our project partner is basically a land-based team. So agro-based team. So the production of algae in the site, like it can be used as a fertilizer, which will generate like profit for them. Also, like it will decrease their expenditure.
Yeah. So that's a client feedback and is happy doing that, and that's a good thing to do. But again, look at the impact of that on daylight, because it's going to significantly kill the daylight. You're going to increase artificial lighting. I'm sure you've not factored those things while developing the EBI. Absolutely sure of that.
So I would like to add to that point of daylighting. So previously we had designed the algae biopanels covering the full facade, but we found out that the daylighting is not sufficient. So we designed it in such a way that it will act as jolly too. So there will be it is patterned in such a way there are voids in there. There are voids in there to allow daylighting inside. So that's why we have used a single glazed unit also to enhance the daylighting inside.
Alright, so I'm not going to stretch more on that. Another observation, so on the roof you have solar PV,
yes.
You have a cool room underneath that,
yes.
And you also have aeroponics.
Yeah.
Think about if they all going to work out together. Right? Sometimes we just bring in a lot of technology from multiple areas. We tend to make our projects more complex. It doesn't necessarily mean they're going to become better. So I just encourage you to think about it a little more. Sometimes simple things can become more and more efficient. Look at these things. Technology is available. If you Google, you'll get more and more stuff. Not necessarily that all of it will work together well. Right? Think about it. Otherwise, it's a good job. Thank you.
Thank you.
One of the questions
Yes.
Sorry, guys. A small question. The tower garden that you
Yes.
have, what purpose does it serve for you?
It acts as, it's actually a urban garden that we are providing so that our project partner will be able to generate revenue through it. And the reason for choosing aeroponics is it requires very less water when compared to hydroponics or a land-based.
Does it also help in your resilience in any way?
Yes, ma'am. Because we are producing food over there, so it also acts as a resilience factor for. Thank you.
Thank you.
Okay, thank you, jury members. Thank you, team titles. Now let's take a couple of minutes to get ready for the next presentation. We degree. Alright, so our seventh and final presentation is from Team V Degree. They have worked on project Punapur Police Station in Nagpur. Their project partner is Nagpur Smart and Sustainable City Corporation Limited. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a signal like this, and you won't have the 21st minute. Alright, I'll ask you to stop your presentations when you exceed the time. After that, we'll have 10 minutes Q&A session. So please keep your answers very direct and to the point. So all the best, team. Stage is yours.
Hello everyone, we are Team V Naught. I'm Minza Shahid, Sagar Rajapadhyay, Rishabh Mahure and Yash Bhatkar from VNIT Nagpur, and we are here to present our project in the office building division. Whenever we think of offices, doesn't something like this come to mind? So when we entered the division competition, we had a similar idea in mind. But as we delved deeper, we realized that the original state is something like this. Government offices of India in despair, discomfort and cluttered. That is when we had our aha moment and we realized that we could be the ones to make this change. Indian offices could look drastically different. And that is why we worked with the change makers itself, Nagpur Smart and Sustainable City Corporation Limited, to build Punapur Police Station as India's first net zero police station. The site is located on the eastern periphery of Nagpur as a part of Party Punapur Township Development. When we look at the site context, we see that the site has a EWS proposed housing on the northern side. The western side is a skill development center, multi-building, multi-level parking and a bus charging station. On the eastern side is an existing residential population and the southern side has a fire station. The building has a build, own, operate model and it is designed to cater 24/7 hours for around 250 floating occupants and 75 permanent occupants. Our project partner paid a lot of emphasis on smart city mission sustainability principles. They wanted a courtyard in design and local materials to be used. And that is how we came up with this design program. We added additional spaces to promote community engagement and came up with a total area of around 2,927 square meters. We did climate analysis and a thermal mapping of the entire design, and then we used as much as passive design possible to get comfortable hours. For the remaining hours, we did a month-wise analysis and analyzed a group of months together as well to come up with strategies and realized that putting a shading device using cooling and dehumidification were appropriate to be used in such a situation.
Now on to architectural design. So when we started this competition, when we received the site, the first thing that we did was to zone the site and to place the building footprint such that we separate the public areas that we have planned for the building along the road and the confiscated vehicle parking and all the secure areas placed on the rear side of the site. Then we set the building orientation to 22.5 degrees to the north based on the sun study in Nagpur. Then an iterative process was followed. So first we designed a building mass from the area program and performed box simulations on it. Then we further articulated the form and optimized it so that staggering of the form happens towards the north so that the form achieves self-shading. Then we integrated the design program into the massing with the aim of segregating the high security areas from the public areas. We also added circulation codes to the building and PVC wind towers. Then two courtyards were added to the building, one with a primarily public function and the other with a private function. An external bamboo skin was also added to the building to reduce the cooling loads, and whatever the energy consumption resulted, then we satisfied it with the PV array placed on the rooftop. We designed the site plan in a way that the pocket park, community garden and art installation, all these public areas for community engagement are easily accessible by the public, along with spaces like public parking and visitors parking placed adjacent to the road. All the secure areas such as emergency vehicle parking and confiscated vehicle parking are placed as secured by a secure entry and restricted, and the area for future expansion is then placed to the south. When we started designing the police station, we got a brief from the project partner and we realized that the brief was quite rigid and the adjacencies that needed to be followed were also quite rigid, and there was not much scope that we could change in the station. So then the thought process went to the liminal spaces. How can we change the image of a police station by changing how the circulation works in the station and how these liminal spaces can be could change the perception of people towards these buildings. So the entire floor plan of the police station is organized around two courtyards which flow into each other. When a visitor enters the police station, all the public spaces are placed along the public courtyard, such as the waiting room, the community policing room and the canteen. along with areas that need quick access such as the inquiry, women's help desk, etc. The secure areas such as detention room are placed away from the public eye along a corridor which is then accessible from the rear side of the building and has an independent access. And the official areas are then placed around the private courtyard with circulation courts placed in the close proximity. The upper floors have areas that can be only accessible by the police officers, which also includes accommodation for the on-duty police. We then designed the building section to carefully integrate all the passive design strategies, climatic considerations, and also to integrate low energy passive cooling systems. On further zooming down, we see the innovative design that we have used for our wind tower, which is a passive down drop evaporative cooling tower. What we have done is we have placed a water tank on top of the tower. As the air enters from the prevalent wind direction, the water goes into the micronizers, which spray cool water onto the wind. It gets humidified, becomes heavy, comes down and flows into the adjacent spaces, absorbs heat, and then escapes to the courtyard through the stack effect. So this wind tower and the courtyards work in conjunction. We have designed spaces like these. This is an image of the public courtyard, which is a double-heighted structure which is light and airy. So this is an attempt to provide psychological comfort to the distressed individuals coming into the station. Shading of the building satisfies about 31% of the comfort hours, but we wanted to deviate from the typical chhajja design of the shading because that would again impart the same age-old identity to the police station. So we collaborated with our industry partner, Punarnava Ecological Services, to design a dynamic bamboo shading device. It went through stages of prototyping, and this is the final design that we have arrived at. It is an openable bamboo shading device. We also made sure that the design is actually working and performed simulations by keeping it in closed and open conditions in all four cardinal directions, and then suggested the project partner a mode of operation which would achieve maximum efficiency. We also provided the project partner with a DIY toolkit that this shading device can be easily assembled by them, and in future whenever there's replacement needed, that can also be done independently. Coming on to energy performance. We followed an iterative process to decrease the EPI of the building. We considered base case of 225 derived from Greenha, and through various strategies we brought it down to 78.8, which is a remarkable 72% reduction. One of the strategies is optimizing the building form and the orientation. So we tried to reduce the heat gain of the building as much as possible, as well as perform the shadow studies to identify areas that were prone to excessive sunlight. We also provided an efficient envelope to the building. So this is the iteration for the wall assembly. We have employed a cavity wall with fly ash bricks, and we achieve a U value of 0.29 watt per square meter Kelvin. In the roof assembly, we have tried to replace the conventional insulation with a inverted clay pot insulation and finished it with reflective China mosaic tiles, which brings our U value to 0.25 watt per square meter Kelvin. In the fenestration, we have used double glazing with an SHGC of 0.23. To improve the energy efficiency of the building further, we have our building uses a mixed mode HVAC strategy, in which the different areas of the building are divided into natural ventilation, passive down-drop evaporative cooling, and variable refrigerant flow, with the flexibility that these zones can be expanded during summers where extra thermal comfort is necessary. Through these strategies, we managed to reduce the energy consumption of the building by 65%. This reduced energy demand is then satisfied by the PV array placed on the building rooftop as well as the parking canopy rooftop. This saves our project partner 29 lakh rupees annually. This is then also integrated with the lithium-ion batteries and the neighborhood microgrid. But when working on energy, we found out a huge problem. That from the months of May to September, we see that the consumption is more than the generation. This problem could have been solved if we had used net metering and connected it to the local grid, but we decided to innovate. With collaboration of our project partner, we derived peer-to-peer energy sharing system, which aims to solve two main problems. The first one is to solve the the consumption and generation imbalance due to the seasonal variations. The second is that there's a lot of dependency that we have on carbon high coal-based energy, which should be reduced. So when we think of net zero energy, it does not necessarily mean carbon neutrality, because we are still using coal-based energy. So what this innovation does is, it establishes a local microgrid within the neighborhood, in which all the buildings which use renewable energies are connected. Our site plan actually is our site context is actually very conducive to this, because the buildings around it have different occupancy timings and different energy requirements throughout the year, so that this imbalance can be corrected. In this renewable energy shared in between these buildings instead of with the main grid, and this system can achieve a savings up to 30%. Realizing the scalability of this innovation, we actively encourage our project partner to replicate this system in different parts of the town planning scheme, in which there can be different combinations of commercial, industrial. So there's a lot of scope to implement in the town planning scheme.
So coming on to the water performance, we have analyzed the usage of water inside the building, and we propose two strategies for that. First one is the rainwater harvesting, and then the treatment of grey water through the root zone treatment. So in this case, we try to reduce the potable water demand. That we have done with the use of using a water efficient fixture inside the building, from which we are able to reduce up to 42% reduction of potable water inside the building. And also we have tried to find the native plants which are well adapted to the climate of Nagpur, and that we have incorporated around this site. From that we have achieved up to 40% reduction in the irrigation use of water. Now this shows the water balance of our site. The overall annual demand is getting satisfied with the help of our strategies, but even we are able to have a surplus water in our hand, so that we have a net water positive cycle. This animation shows the rainwater harvesting. Basically, this is the catchment area in which water will be collected, and then the area nearby will have a area where this water will percolate inside the soil, and whatever excessive runoff is there, that will be collected into the biospheres, and at the point of because of the grading of the site, all of the infiltration will go to that point, and there is an infiltration tank which is there. So the water will be collected over that tank. So now coming on to the water management, to do such a large scale project and such a big water to be stored, we need a bigger tanks. So we identified that in combination with the fire station, we can have a water tank bigger size, in which the months which have higher rainfalls, we can store the water, and the months in which we have limited rainfall, we can even take the water back from that, and so that we can satisfy our demand of the water. This is the section showing gravity sand filter, which we will be using for treatment of rainwater, and the root zone treatment, which is there for treatment of grey water.
Okay, now coming on engineering and operations. Okay, next. Yeah. Now coming on engineering and operation, by the structural analysis, we determine the sizes of the columns, beams, and our footing. And our main aim was to reduce the required amount of the reinforcement and the steel. Required amount of steel
Additionally, incorporating the pulverized 30% pulverized fly ash in our slab reduces the carbon footprint, and then we also incorporated the prefabricated bamboo reinforcement lintels in our structure.
So now coming on to the HVAC design of our building. So we have designed our HVAC system based on annual operation mode using the adaptive comfort model of IMAC, in which we have calculated the hours of the day throughout the year, and then we reached to a conclusion that we will be using the mixed mode strategy, where we will be using VRF system, PDC system, natural ventilation, and internal gains for the overall ventilation. This is the plan showcasing the layout of the VRF system. It is mainly incorporated in the office spaces, which is facing to the south direction. Now this is the section showcasing the connection between the indoor units and the outdoor units of the VRF system, which are incorporated in the office. Now this is to make it more accurate and precise, we need to we found that we should connect it to the automation system. So we choose a BSES net system, where we have which system will control illumination as well as the cooling system, upon which there are also presence sensor installed in both of the system, which will analyze the presence data of the people in the building, and then we can save a lot of more energy through that.
Now to embodied carbon. Early on in the process, we realized that the wall assembly is a critical place where we need to save in embodied carbon. So through an analysis, we decided to go with fly ash brickwork, which will be sourced locally from a thermal power station near Nagpur, and it will have a lot of waste utilization. For the shading device also, we have used bamboo instead of aluminum, which saves us a lot of embodied carbon and also promotes carbon sequestration. These are the savings that we have done in each, in the wall, in the roof, in the floor, as well as in the fenestration. We have also mapped the distances of the materials to our site, and to make sure that we save on A4 emissions, transportation related. And we then map the total embodied energy flows of our building to arrive at a final figure of 6,02,126 kg of carbon dioxide equivalent. We also went above and beyond the brief to save on operational carbon emissions through our peer-to-peer energy sharing mechanism. The energy that the embodied carbons which are already offsetted by the renewables are further offsetted by this system, and we end up with 188.5 tons of carbon dioxide in our annual operational savings.
Since Nagpur is susceptible to heat waves, we had to design for the thermal comfort of its occupants. That is why we did our designing in all the three variants of HVAC components, which is VRF, PDC, and natural ventilation. The building is also made flood resilient, as the site is located in a depressed region due to a presence of a highway nearby. We did this by incorporating elevated plinths and bioretention swells on the periphery of the site. The design is also fire resilient with adequate exits and also fire safety mechanisms. We have attained resilience against power outages and have attained an autonomy of around 20 days for water and 24 hours in terms of energy. As far as health and well-being is concerned, we have made provisions for improving the indoor air quality and providing quality views. With simulations, we have been able to reduce majority of the disturbing glare and provide 66% of quality views in the office spaces for the productivity of people. With simulations, we also gained 47.4% of the spaces with daylight autonomy. The space is has accessibility due to the provisions of ramps and washrooms for physically handicapped people. As far as lighting at night is concerned, the office spaces have an average lux of 350 to 400 lux lighting, and the corridors have 150 lux lighting. The indoor visual comfort is maintained, but the outdoor visual comfort, we have tried to reduce the light pollution by incorporating light flare mechanisms.
Yeah, now coming on to the affordability, this chart shows the distribution of the cost of all the services, and our total project cost was around 11 crore 98 lakh and 60,000.
Then this graph shows that we able to save the 17.5% in a building envelope cost and 12.5% in a building components. And then we conducted the SCC analysis in a PVC stream that 25 in a 25 years of analysis, we PVC stream saves the 4.3 crores and means that it pays itself in a 5.5 years.
Now coming on to the value proposition, along with creating net zero building, we have also added a value to our project partner by catering to adhering to the smart city principles while making it into the budget. Now this is what we try to do an attempt to reduce the construction timeline from 60 weeks to 52 weeks so that it will cut the some amount of soft costs. And here is how we broke the mold by making the India's first net zero police station, which is GRIHA certified with 57 compliance points, and which will also be act as a benchmark for other net zero police stations.
You gave a very insightful presentation. Let's hear from the jury members. Samit, I'll start with you.
Thanks. Are your project partners here?
No, unfortunately not.
They're not here, but maybe want to, record this. The very fact that they've asked you for looking at something different, in my mind, is the start of a change, and I think that needs to be applauded. I'm very happy to see that. That you've taken that challenge and worked on it. I think that requires another round of applause to you. Very happy to see that. So, I think overall it's been a very nice effort to look at every area of this building. I just want to know how much of this was guided by your project partners, or was it a clean, simple site which you got and all of it was done by you, or did you sort of get some, because you were talking about GRIHA credits and all, was some work already done on it? Did you start from something which was done?
So initially when we received the brief, we used to have monthly meetings about the project. Because at that time we didn't have a product developed or the building developed as such, so they were not very interested in seeing the project. But as we started going to them with the actual design, they started getting more and more interested in the project, and we had a lot of discussions, and through these discussions only our innovation like the peer-to-peer energy sharing, that was also born from those discussions. And as far as the GRIHA point is concerned, we realized that was something that we did on our own. We realized that the project partner, when we are working for a government body, so maybe they need something quantifiable, that this building is sustainable, but how? So we thought GRIHA was a good benchmark for them to do. That is why we added to the value proposition.
Very nice. And just one thing I didn't observe here, and I'm not sure if you missed it or you worked on it. You talked about an HVAC system which has multiple modes.
Yes.
I think all that is great. What is the size of the HVAC system you designed for? I didn't see any data on that.
So that is, we have around one outdoor unit of 1,20,000 BTU per hour, where several indoor units are connected with a capacity of 7,500. We took a largest area of the building. Majorly, our offices spaces are almost similar. So according to that, taking into consideration the one factor that one of the bigger piece will have the capacity, so every piece was the same. It's just that we connected the system well.
So 1,20,000, about 10 tons of air conditioning.
Yeah.
For what size of space?
It is around 500 square meters.
500 square meters.
Yeah.
So I think. Yeah, okay, so look at those numbers again.
Yeah.
Otherwise, I think I also want to know of how you really worked on the your PTEC tower, because that's the crux of your design.
Yeah.
How to design it? What made you? Why is it in the shape it is right now?
So it is directed to the prevalent wind direction from where we can catch the wind, and through that it is it's like the areas where less amount of cooling is required. We have identified those areas, and then to cater those areas, we majorly added those PDC system based on the.
Also about the form. So initially we had designed a cuboidal structure, but then we thought that the building looked very boxy. And then we consulted with our guys of civil engineering in our team. So they also suggested that having a battered form would be better for structural stability as well, since it's a structure that is rising to 18 meters. So that is why we decided with this form.
Very nice, very nice. And then the peer-to-peer sharing also. Yes. It's a great idea, looking beyond just the building itself, looking at a community. I think it's a good idea. Very nice effort. Thank you.
Thank you so much.
So hi, I think I had also mentioned in my comments that your documentation is really good, especially also if I look at this last slide itself, because you have set very specific focus targets. So it's easy that, okay, this is what I want to achieve, this is the quantity I want to achieve, and have I achieved it or not, or how near. So that's pretty good. A few things. I was just wondering, the PV array that you had, you showed it all across, all the rooftops, okay? You have, there are various levels in your this thing. And I think a lower level is there on the northern side. I'm just thinking about mutual shading that might happen over some of the rooftops, okay? So that is something that may happen. I don't know if you have taken into consideration that whether there will be an efficiency reduction in some of the generation of electricity from some of the solar rooftop PV.
Yeah, so when we made the form, we also ran a solar potential simulations on the rooftop, and then it was kind of a trade-off between lesser heat gain versus lesser consumption. So when we made that, when we saw the difference in those, so this seemed like a better idea. That's it.
Some things which I did not see here, but I remember that I had some comments about them in my listing, was your roof, because you have the inverted plate, this thing. What is the roof thickness, when the RCC slab thickness there?
Yeah, in the report we had 75 mm, but then when we checked again, I think we have increased it to 150.
Okay. So that's something, because it was there. With the added weight, you would not be able to have that with 75 mm. Also in your report, you also write something like prefabricated modular construction technique. Where is it used?
In terms of prefabricated, so again this was a trade-off in the carbon emissions. So we could only do this with material that had already lesser carbon emissions in the beginning. So again we worked with bamboo, and we introduced bamboo reinforced lintels which could be prefabricated and brought to the site.
So that the prototype that you have, are you talking about that?
No.
Or do you want to show it?
Yeah, I'll just show. Yeah, this is what we had done. So we had replaced the steel reinforcement with bamboo, and also the shading device that can also be prefabricated and put on the structure.
So one last thing, sorry, I just remembered. Can you go to your embodied carbon this thing slide where you have the number, some 6 lakh something?
Yeah.
This is final, this thing is 6 lakh, okay, 2000 or whatever, and your built-up area is how much?
2,700.
2,700. If you do a quick this thing, like if I were to do it, how much does it come up to per meter square embodied carbon? Building material, I think it's 200 something, or
We'll just check.
and this is a frame structure, right? Artificial frame
Yes.
structure.
It's around 200.
something.
Yeah.
Okay, there is something off with that. Okay. 200 is way too low. It is almost conventional today. It is, and considering that you have a frame structure, so cement, steel, concrete, you are using it. You know? So it is very low.
Okay.
But that is fine. I mean, embodied carbon is something, is an emerging field, so like we really don't know much about it. But I appreciate the fact that you showed in terms of window, roof, and all of that. So that's well done on that.
Thank you.
Should I say you said it all actually? A bold project to pick up and a confident way to present it.
Thank you
It
so
comes
much.
to my mind. Appreciate the work around every piece. You picked up every piece very well and tried to decipher it in terms of first laying down the objective and how to achieve it. Few things which I found really impressive. This being a public space, it took care of how different people who approach can easily access it. Differently able people, they will also come. How do you try and mix it with common man living around? And they should feel that they have to reach. I mean, you try to reach to the psychology of the people who try and refrain from reaching out to police. So these are the things which actually makes me feel that you connected with the project and then started working around it. The only question, which I could figure out is, how did you think about this project?
Initially, as we started the presentation, when we imagined office, when we entered this division, our typical assumption was offices looked like these. But then we thought that government buildings also needed a change. And then we thought that how do we even approach a government organization? So then we went to a smart city project, and then we asked if they had any project for us. They gave us a few options, and we thought that this is the most challenging and we should take this up.
Nice way of getting to the project. Second question. What do you mean by we not?
V is the abbreviation for our college, VNIT, and not is for net zero energy. Yeah.
Good work, and thank you. You answered my questions. I hope you answered my query, which I tried to look at. And look at the life you have considered for a VRF system.
Yes. So that is actually we checked in the Decathlon system. So it was around 10 to 12 years. Like it can last up to 15 years, but the average is around 10 to 12 years.
You had considered 25